Okay. Okay, so we have a Vodqa sessions based on people's recommendations and how the trend goes on. So if you have any recommendations, like I'd like to have session on mobile testing, or if you want to have on A testing or something, you can just provide your recommendation on the field in just below the sheet or behind the sheet somewhere, so that we take it into consideration and then plan our next sessions of it. Okay. Thank you.
Hello everyone. So we got the idea for us as a skill for Alexa. Everybody hear me? So we came up with an idea as a skill for Alexa for a voice-enabled meeting room, and we proposed this to the organizer. They came up with that. Actually, I will thank for them. This is going to be the agenda for today's presentation. Who we are, what was the problem, how did we solve, and how did we test. Let's see who we are.
So, can I just know how many Thoughtworks are here and focus? Okay. So, we are from TechOps Incubator. So, primarily for non-Thoughtworkers, if you are wondering about what TechOps is, TechOps is Thoughtworks internal operations. We intentionally take care of Thoughtworkers' life is good, and the systems they use are good enough, and they scale good. And as incubator, what we do is we take up ideas, we collect ideas from Thoughtworkers, and we innovate and we deliver those ideas. So one of the ideas that came up with Alexa to solve one peculiar problem that we'll see in the later on.
So this is the model we follow. This is an incubator innovation model. We start with ideation. We collected ideas from Thoughtworkers, and we mentioned that we have conducted many ideation workshops and collected around 150 ideas. And we validate those ideas with the core stakeholders, and by considering different parameters like viability, usability, commercial availability, and adaptability and feasibility. So these are the parameters we consider while validating the ideas. Once we validate, then we take it to the innovation. So we put the innovative ideas, the innovative thought process for the ideas, and come up with a workable product from the ideation. We take very minimum time to develop that. So we usually take 8 to 12 weeks to come up with a workable product and deploy it to the system. And while coming to measure, you all know that like how we measure the ideas and innovations, right? So we measure the impact of innovation, how much impact it is making, and ideally like we'll hand it over to the respective set teams. So we as an incubator work with the idea, come up to a workable product and hand it over to the respective set teams.
So this is some of our portfolio. So as you see, the IoT platform is the one that we have started with. So basically, we put a sensor in the meeting room, just monitor what is the things happening in the meeting room and get the data out of it and provide some data-driven decisions to the organization. And one way dashboard is one that addresses the problem of room booking, right? So as in any organization, once you want to go for a meeting, you should book a room before you get into the room. So you need to know what are the rooms available and what are the rooms which are busy. So this provides a holistic view of the rooms available and what is the room status. So the ones in the green or the free ones, you can go ahead and book those rooms. And the other book me room is subsequent to that one-way dashboard, which allows to book the room. So once you see the room is free, so you need to log into Google and do some other stuff to book the room. So we made this process easy just by a tap of a button, which made booking the room pretty easy. So
those are the ideas we collected from Thoughtworks. Those were the problem statements they came up with. So if they want to use a meeting room, ideally they don't know what other rooms are available at the time. So that is where we came up with those solutions. One of that is Alexa. So what was the problem in it? So you see this meeting room, right? I came to Chennai yesterday from Coimbatore and I was looking for a meeting room. And I got this room. And you can see this kind of room in any Thoughtworks, like it has a TV screen and a camera for the video conferencing and the projectors and the conference phone systems. And so basically, like once I identify there is a room which is available from the Book Me Room app, and I enter this room and I want to use this room for some time. Do you know what I have to do to use this room? I have to block this room first, because otherwise it will knock me out in the middle of my discussion. So to do that, I have to open my calendar. I have to pick a date, time, and I have to choose this room. I don't know the name of this room. I'm new to this Chennai office, so I need to search for the list of rooms, identify that, and then need to send it, and room has to accept it. So all these processes are a little cumbersome for me to use this room for 15 minutes. So for the problem of using it for quite some time, it's very difficult to block this room. And do you know like where the Alexa is in the room?
the iPad.
iPad, sorry. Do you know where the iPad is? Okay, basically the iPad and keypad are used to connect to the Zoom meetings. Zoom meeting is a conference, video conferencing software, which we use, Thoughtworks is used to have the conversations. And it's very difficult to identify the iPad. Sometimes they keep it in the middle of the table or just below the screen, so it would be a little difficult to identify where the iPad is. So it takes some time. So if the meeting is about to start, it would be very difficult to find out where it is. So these are the problems which we identified, and how did we solve? So this is where the solution comes up. Instead of having a touch interface, we came up with a voice interface. Once you enter the room, so here the Alexa comes up. So once you enter the room, you can ask Alexa to start the meeting. So by this, we can have any ad hoc meetings. You don't need to plan. If the room is available and if you want to start a meeting right away, you can do that by just giving some simple commands. And you don't need to think about whether the calendar is booked or whether you want to book. Alexa can help you to find out if it is available. It will tell you that it is available. So you can have an instant calendar booking. We can also have an instant Zoom meeting also. So if you want to create in a Google Calendar, you have to create a Zoom meeting, put the details into the calendar event. But here it can create by itself. And it also comes up with a wow factor, right? So I don't need to spend all this time in my laptop just to start just to block the meeting room. Let's see a small demo here. So so just assume this is a meeting room. Okay, this Alexa has been configured for one of the meeting rooms here, and we are going to show you the.
To Alexa for business. For IT support.
Okay. Hopefully the demo works a bit like this. See, Alexa, ask Thoughtworks to start Zoom meeting.
Oops. Room is not yet booked. May I book the room for you?
Yes.
Room is available for 30 minutes. Do you want to book now?
Yes.
Room booked. Would you like to start instant meeting?
Oh, yes.
I have left the meeting for you. Thank you.
Okay. Just didn't start. Alexa, ask Thoughtworks to start instant meeting.
I don't know that.
Hopefully the demo gets failed.
These are the edge cases where we do, like when you give the correct command, Alexa can understand.
Okay. Let's try one more. Right?
So this is the meeting room where so you see Zoom is not yet started, and so just assume you are in this meeting room and Alexa is there. Alexa, ask Thoughtworks to start the meeting.
Sorry, I could not find any meeting for this room. Would you like to start instant meeting?
Yes.
I have started an instant meeting for you. Thank you.
So you see, it wasn't there earlier. So
Yeah, it
waiting.
started.
So it started. So earlier you were seeing an error message. I think something blocking the camera.
So if you can see the iPad, the meeting is started. I could see the leave button and all. If you're familiar with the Zoom iPad stuff, you can see. But I'm sure that meeting is started now. So let's say, Alexa, ask Thoughtworks to leave meeting.
I have left the meeting for you. Thank you.
So this demo is just to set the idea, right? So you all get the idea of what it does, right? So you just enter a room. You see a dashboard, one-way dashboard. You see which room is free. Find the room, get into the room. Ask Alexa to start meeting. Once it's done, just ask Alexa again to leave the meeting. This is the experience what we built. So now let's get back into the core problem and see what are the challenges we face while doing it, especially around testing. Yeah. Zoom now. Answer. Yes, sharing. Cool. So this is the overall architecture of our Alexa thing. So once you ask for Alexa to start or end the meeting, and Alexa does some NLP processing within it. So we don't care about it. It's just a black box for us, and it gives a request intent. So the start meeting goes matches to a certain intent. Intent is the one action that you want to achieve. So which goes to an AWS Lambda function, which then interacts with various other APIs like Google API, Zoom API, and get started the meeting. So yeah, so this is the one which we have come across for years, right? So the same principle applies for Alexa as well. So we wrote a bunch of unit tests. The cost is low and the time of execution is pretty fast. And then we move to a few integration tests, and the cost is a bit higher. And then it's an end-to-end test. So basically any skill, right? Any voice-oriented skill is just a state machine. So the application or the skill is in the current state, some state, XYZ state, and you ask the system to perform some command, and it switches the state, right? It's just a state machine. So the first thing what we have noticed is, okay, let's get the state working properly. If we can manage to test the state transition, the individual state transition properly, then tying it up together would be a seamless process. So that is the first test we end up with. I'll switch between the test, the real-time code, and the presentation in between. Yeah. So the script is in TypeScript. The code is in TypeScript. So what we ideally do is, right? So when we are in one state, so we try to. Is it visible from the back? Okay. So ideally, what it is doing is the system is in current state. You give a command and you check whether it moves to the next state.
I think you showed a diagram, right? The architecture diagram flow, where this whatever you're talking about comes into play. So you said that you have an Alexa component, Lambda component, all these various components. What did you show me? Lambda component?
Yeah, the Lambda component. Inside the Lambda component contains the entire flow, what the skill should do. When I ask Alexa what it should do, how it should react, right? So those sort of code is in the Lambda component. How did we test the code? So in Thoughtworks, we do a test-driven development. So we write the test, the use cases first, and then we go to the development. So to ensure that the state transitions from one to another. Let's say now we have shown a demo. I'm asking the Alexa to start the meeting. It says the meeting has started. So which means that currently there is no meeting. It's from the no meeting state, just went to the meeting started state. Got my point, right? So how did we test the state transition? For each command, there is a state transition. So let's say there are 10 commands and there are 10 state transitions. If we are able to test these 10 state transitions individually and tie it up together, and our flow will work seamlessly.
Where do you maintain state?
Yeah, the state is maintained by Alexa. So what happens is whenever you make an intent request, right? So it maintains the context. So the state is maintained inside the context for a conversation, right? So it can maximum hold the context till 9 minutes, right? If the conversation is idle, if the conversation is keeping on, it can keep the context till we end the conversation. Yeah, pretty much this is it. So when I start the meeting, it should go to the start meeting state with the value of success. So by this way, we are ensuring that the state transition is working perfectly. Once it is done, we will make sure that all these individual state transition when tied up together are working fine. So that is a second step. Yeah, question?
Sorry, I think one thing is not clear, right? So I'm going to say, Alexa, start the meeting.
Yeah.
That's what I'm saying to Alexa, right? There's going to be something coming. Alexa is going to interrupt.
Sorry, I don't know that one.
Okay.
It's going to interrupt some. It is going to kind of understand what I speak. Okay, some NLP engineer is over there. It is going to get something and call the Lambda API.
Right.
So when it calls the Lambda API, what is the input it gives to Lambda API?
Yeah, I'll show you so that it is visibly clear.
Because for me, that
Yeah, I got a question.
because let us talk about, right? Let us talk about Alexa, 3 steps, right? Let's talk about, say, is the room available? Book the room, start the call, 3 steps. Okay. When we talk about 3 steps, so there are going to be 3 APIs I have here.
Yeah.
So based on, there's going to be some input coming into the Lambda. I think it's Lambda over API gateway.
Yeah.
Right? Some input is going to come in, and it's going to in turn do some API integration. Right? It could be Google Calendar, it could be Zoom, it could be any of your API integration interaction. Right? So that is the crux of the whole thing, right?
Yeah. So let's come to it. So when you're writing a script for Alexa, this is the model you give for Alexa. So what we specify here, what are the intents you want? What the intents are the actions that needs to be performed by Alexa. So what we say here is, for the start meeting intent, so these are the samples. So when you say Alexa to start the Zoom meeting or start meeting or start, so it might hit the Lambda with the start meeting intents. So I have handlers for multiple intents. So what should the skill do when it receives a start meeting intent? What should the skill do if it receives an end meeting intent? So there will be various intents. So here we'll give the phrases. So based on the phrases, we need not do any NLP for us. That's why this AWS, the Alexa's platform comes into picture. So it takes these, reads this model and calls your corresponding intent.
Basically, the Alexa is going to pass start Zoom meeting to your Lambda API.
Alexa is going to directly call the start meeting intent. It's just going to call the start meeting intent. If you say start meeting, so we can read it like, so if I ask Alexa start Zoom meeting, go to start meeting intent. If I ask Alexa to leave meeting, just leave the leave meeting intent. That's what it means. Is it clear now? Yeah. So we saw about the individual state transitions. Then the next thing is coupling these state transitions together. As the skill is deployed in Lambda, we used in JavaScript, there's a cool, interesting library called Lambda Local that allows us to make a fake request or run the Lambda in your local machine. So what here we do is we simulate the conversation. So here I have simulated a conversation of start the meeting and responding yes. So what should Alexa do if I simulate these 2 steps? So these tests are automated tests when run. Yep. So this is the response of the state transition. So all we can see here is so transition to state The start meeting, it's passed. So here is this test is the one which I'm speaking about, to coupling two different transitions. So yeah, the first one is the start meeting and next one is the saying yes. So this is the response. Okay. So it says room is not yet booked. May book the room for you. And if I say yes, room is available for 30 minutes. So by this way, I can test. So the coupling is working properly. So each state transitions are working properly. We have verified it. Now we are verifying whether if I combine these two state transitions together, I get the proper conversation. So let's say the individual conversations are working fine. And when you combine it, it says some other thing. Can you lend me money? Okay, go to, it says something else, right? Out of the context. Then the test is failed, right? We are ensuring that it works in tandem with each state transition. Right. So the other test is to check the Alexa is responding the proper speeches. So this is the simplest test which you can see. There are a lot of unit tests about it. So when I say when the start meeting is successful, it should say I have started the meeting for you. So all these checks we asserted. So this is how we made our test experiment. There are a lot of assertions about whether the Alexa responds the proper text given the proper state. That is the main fundamental test. And above that comes the state transition test. And above that comes the coupling state transition test. All right. After all, Amazon also provides us a console which we can use to test our skill. So as you can see here, so this is a chat kind of console where you can say what are the commands instead of if you don't have an Alexa during development. So you can test using, you can just give it the command and check what is the response from the user. Now we are working on automation for this. So to coming back to the original question of if I say start meeting, it should how do I test the NLP process in the Alexa is working properly? So the idea is to have a webhook to your Lambda, and I ask the start meeting, and I automate the test using Selenium or some other tools here. And during the webhook, I get to know whether the proper intent testing worked. So when I run my automated test, it's going to feed in the proper text here and check whether my webhook has received the proper command. By that way, I can ensure that the black box, which is the NLP, is working as fine as expected. Cool. And of course, the final part is you play with the demo words and the Alexa. So if everything is working fine, that will go fine. So during the context of it, we came up with one simple library, Alexa Intent Tester, that if you're developing Alexa skill, you can use this one to fake Alexa requests. So if you're developing a skill through Lambda, you need to make the request in the format that an Alexa skill understands. So this is a quite little helper library that would help you to make those fake requests. Yeah. This is about the sequence of transitions, and this is our.
When it comes to the functional validation, right? So basically, from a functional background, I have mostly I approach the application and the idea in how I'm using this system. So usually from the functional background, I write the test path approach will have how the conversation goes between different users and how Alexa is integrating or interacting with other systems like Google Calendar and Zoom meeting. So this may not be visible for you, but this is the idea behind it. So it has all the interactions, conditions, and the approaches and the paths which the conversation takes between the user and Alexa. Finally, we test directly with Alexa. So by asking different utterances and giving some different answers, we test Alexa.
Pretty much that's it. Any questions? A couple of questions we can do. I think we are running short of time. Yeah.
So on the usability side of this total application, so there are 8 to 10 conference rooms, and you have the implemented conference. Now suppose I want to book one conference. I go to the first room. I try to book and it is already. My request is cancelled. Then I go to the next conference.
So I got your point.
More cumbersome than Google Calendar.
So I got your point. Like we gave a demo like the room is not booked. There are other situations, use cases like the room is already booked. If that is the case, if you ask Alexa to start the meeting, it will start instantly. So if you have seen like when Abdul gave the second command, it started the Zoom meeting instantly. So that is one case. And second case is like basically what the idea behind about Alexa in a meeting room is like, it will be used better in a big boardrooms, not like simple meeting rooms where have all the systems in place. That would be the right. So it will be work well when we have it in the boardroom. So that's the idea. But when we implement in all the meeting rooms, will also work. But when we discuss about the use cases, there are different use cases. When I already booked the room, or if I don't have the Zoom meeting, I booked it, but the Zoom meeting is not there. So all those things which comes into this flow diagram. So it has, if the room is not booked, it will book it. If the room is already booked, but Zoom is not there, it will book. It will create a Zoom meeting for me. So that is how it handled by itself.
To summarize, the entire user experience is not only with Alexa, right? So we have shown you a demo of a one-view dashboard that shows what are the rooms that are free now. So imagine a Thoughtworks office. When you come to Coimbatore or Pune office, you can literally feel this. You see a dashboard. Okay, these are the rooms available. Then you see which the room you want to get into. Just get into the room, ask Alexa to start the meeting. So yeah, the one single solution does not fit well, but as a holistic, 3 systems combined together gives you the user experience what you would expect.
So this is what I was telling, like in Coimbatore, we have all these meeting rooms. So today there is a drive which is going on. So that is why you see few rooms are occupied. So I can see this room. I see there is Kotagiri, Kudalur, which are free. I can use Alexa.
Yeah. This is an independent product, and Alexa is an independent product. So these 2 things work together to solve the same problem. So it's a 1V dashboard. We call it as a 1V dashboard. It's an internal application. As we said, right? This is to enhance the life of the Thoughtworks.
How does Alexa identify who booked the room? I mean, you are just giving a request, which is very general. Is it me who booked or is it you?
So you want to validate.
And then you go inside and you start the meeting. And, wow, nice.
We also came across the same question, and so I believe Thoughtworks are so good so that they don't go and start someone else's meeting. So we believe in that. That's how it works. To be honest. Yeah, technically we have thought of it, and there's also an option that if you have an Amazon account, you can identify who is issuing the request, and we can even tie back it to our own custom identity account, and we can do all this stuff. But again, the kind of question comes to this value versus effort, right? So does that all this effort give you enough value? No, we just thought of this and things are done. It's possible. What I'm saying is it's possible, but for us, it's not worth the effort. The value is not worth the effort.
Will this be getting reflected across everyone's calendar when you are booking a room through Alexa?
Of course, yes. Yeah.
So there are 2 use cases. One's like if I created by myself inviting the room, and if I start, I can do that. And there is a separate rule account for the individual rooms. So if I book it, it's there. It will be there in the rooms account. So if anyone sees in the Google Calendar, they cannot book it. It's not inviting individuals, so we don't know who is starting the meeting, right? So it won't block my calendar, but it block its own calendar.
Thank you.
Thank you.
Thank you, folks.
Is it audible?
Yeah, thank you, folks. Thank you for making room booking much fun. So please provide in the feedback and for the earlier sessions as well, if not already. Thank you.
So a very good afternoon, everyone. My name is Ankit. I'm a developer with Thoughtworks. So today I'm going to talk about facial and voice recognition. So as you would have heard in today's morning talks that as the evolution of IoT and data is over there, how can we evolve our interactions? At the same time, because the technology it's still in its nascent, but not very nascent, but is maturing, I would say. How do we verify interactions that is happening with face and voice? So that is today's talk about. So the agenda would be a general introduction. Why now? Why this? And face recognition step by step, voice recognition step by step. And then moving on to the testing. Are you guys able to hear me towards this? Yeah, okay. So then a small demo, and then we will be having Q&As. So introduction, as I already told you about that, we are into an age of revolution for IoT and data. And the processing power that we used to hold like 10 years earlier has increased on a scale of 10 to the power 7. Whereas the cost of your data storage has downgraded a lot. So how can we use these technologies to just not interact with the normal logins of your Gmail, but you already have in your phone how to unlock your phones with your face. Even when you walk out of a Heathrow airport, you are recognized on the basis of your faces and you are given your boarding passes. So the world is evolving. How we can use that technology, how we can leverage this is the entire gist of this thought. So why now, as I told you, the increase in processing power is almost 10,000 folds from 2000 till 2017, whereas the cost of storage has decreased by 3,000 times. So there is no limitation on what amount of data you can store, on what amount of data you can train, and in what time you can train. With the multi-core and the multi-processing engines that we hold today, everybody has access to the platforms like GCP, Amazon, which provides a very strong processing power and storage. So that is about why now. So why this, specifically voice and face we are talking about? There are multiple things as ML evolves, but if you see the model maturity in 1994, we almost had the computer vision library was OpenCV, or certain other processing engines, scientific distributed probability engine. But as we entered into the age of neural networks, we have open source OpenFace by Stanford, we have TensorFlow from Google, which are trained on vast amount of data as I earlier mentioned, that we have access to huge chunks of data also to the processing part. So the research which has gone into these things have evolved the model from accuracy of 53%, which you used to get on OpenCV, to above 70%. It goes sometimes to 96%. One of the such model we would be looking into today. Now, why this? We have QRs. Why not to use QR? Come scan your QR. It is almost, it has null false positive. Why not to use QR? Just say you're entering into an exhibition and you just use your QR. But you have to carry your QR either on paper or on your mobile. But when you are going, you are always carrying your face unless you want to hide it with your glasses or your hat. We can even remove those glasses and hat. If we have voice, which you always carry with yourself, you don't need any physical device with yourself. You can just enter, walk in, and you can use your face or your voice. It can be creepy to an extent because, as I told you, you walk out of Heathrow Airport, they don't see your boarding passes and they just hand you over your tickets. So it becomes creepy. But at the same time, technology is a two-edged sword. How can we use it to our own usage? Second is your devices are now capable enough that they can process the models. Even your smartphone is capable enough to identify your faces, which we did not have 20 years ago. So we have the hardware support, we have the technology, and there's no need of physical intervention, as in you always have your face and your voice. Obviously, some work has to be done on the accessibility portion for the differentially abled, but this technology can be used to its greater extent. So we will talk about face recognition step by step. The first thing is you find the face. The second is you analyze the facial features, compare it against the features which your model is trained on, and finally predict. Okay. So how to find a face? So the first thing or the first step is histogram of oriented gradients. Our face, if you take your picture with your background, our face is having most amount of 3D projections in vector space because of the depth which we have on our face. It's more, to put to simple terms, our face is more 3D viable than our surroundings. So it's very easy to get out your face out of that. So the first step is colors do not matter in finding a face. Your mobiles, as you click your picture, it will show 31 years old drawing a rectangle across your face. This works using HOG, that is histogram of oriented gradients. The first step is to convert the image into a grayscale, that is removing all the color, because it does not matter what color your face is. It's just the depth, the gradient, which matters to find the face. After that, we will look into how to find gradients. So, say I have taken a very small 16 by 16 channel cross view, and then you identify, so it's like a hill. So where is the hill, where is the bottom? It tries to find that and draws gradient vectors over there, as in this. So if you see, it will find a high and a low, and it will draw a gradient vector. Finally, after drawing the gradient vectors, your image would look something like this, okay? And your entire face would look like this, correct? This is done on 16 by 16. If we go 128 by 128, our face is almost recognizable. So this is the first step. Before moving on to the next step, are we clear on this? Or are there any questions about it? Taking that as if no. So the first step was histogram of oriented gradients. Second step is pose and project. Once you enter in training your data set, you will never get the data set you desire. Say you're training for Saurabh Ganguly or someone, and his side pose is there. His face is rotated or tilted by 20 degrees. He's looking up, he's looking down. So in 2005, there came an algorithm called as face landmark algorithm, which identifies certain landmark within an axis rotation of 20 degrees. So using that, most of them are from your eyes and your lips. Using that, you try to align whatever image you have into the direction that it is oriented to. Why so it will work? It is again based on the gradient logic. The change in gradient is almost minimal when you try to rotate within an angle of 20 degrees. If your face is completely rotated like it is a side view, your gradient increase will go above 20 degrees, and that picture should not be considered for training your model. Until unless you create an ensemble model which can recognize your face either from side, either from front, or whichever direction it is. Here we are talking only about the front angle. The second thing is, as I told you that we are entering into the age of neural networks, and thanks to companies like Google who intervene into our life at every point, they have models or neural nets which can extract those features out of your face. So they have extensively trained neural networks. There are other educational institutes like Carnegie Mellon and Stanford who open source their packages like OpenFace, which have a trained neural networks and can identify these measurements out of your face. These measurements are nothing like embeddings, which are the vector readings. The vector which we saw is just a reading of those vectors. Why this? When we train our model, all the neural networks that we train can take input only as vectors. So this 128 cross 128 will become as a single vector as an input to your neural network for training. Then further on, you take more pictures to all the previous 3 steps and train your model on that. Any doubt on face recognition, the theory? We will go into the code after some time if we have any doubts on the theory before moving on to the voice recognition. Okay. So, voice recognition.
Do we consider age factor, for example, comparing S age to more age?
Absolutely. So the ensemble models, as I talked about, right? So when you are going into productionizing this product, you have to take care of all those things. So you have to take care of all the angles of the faces. You have to train your model on that. Also the age factor. This model is owing to its gradient. Say because our face changes between 30 to 50, it almost remains same, right? So this model is agnostic of that. But to include that, there are certain models. OpenFace does have this capability. You can train on this. You would have seen that how people can predict how your face will look like in some time. So that is another application of landmark algorithm. What we do is we have 64 projection points on our face, and we extrapolate on a Gaussian distribution to see how our face will look like. So this is just one bit. We can have multiple models, combine its result into one single ensemble model, and then work on that. Cool. So moving on to voice recognition. Voice recognition is entering into its mature phases. So voice recognition is more like, as one gentleman rightly pointed out, how will it identify that this is me talking to the machine rather than giving commands, right? So we can identify the tone and texture and what the person is saying, but to identify that that particular person is saying is quite tricky right now. So it's again under research, but we can identify what the person is speaking and who is speaking with a very minimal accuracy, that is around 30 to 50%. So entering into voice recognition, what the person is saying. The first step is, because as we know that the sound signals which come out of our mouth are analog signals, there are sinusoidal signals. So for the machine to understand, the very first step is to convert those signals into digital signals. Then further on, every word, say I say W, or A or B, every word will have a rise and fall in the amplitude of the sampled signal. On this, the model is trained on to identify what the word is. So the first step, as I told you, is sampling your signal. Your analog signal is sampled into distinct signals. There are many techniques for that. There are fast transforms which enable you to do that. That is a lot into the signal processing. But there are libraries like sklearn, which are a scientific computing library, which can enable you to easily do this stuff. In Python, there is a package called PyVoice, which takes care of this. Now, there are two portions to identifying something in voice. One is our grammar. Say, we identified I'm speaking A, but whether it is a Hindi pronunciation, whether it is an English pronunciation, whether it's a German pronunciation, or A in what context is what. So the first one is acoustic modeling. We identify that a sound which was spoken is A. That is the first portion. It's a sound A. Now, how to identify which grammar it belongs to is called as language modeling. Currently, Google's voice recognition software provides you around 80 languages in which you can identify sound. Even within English, if an Irishman is speaking or a British man is speaking, there's a difference in the acoustic modeling. So how you speak is acoustic modeling. What you speak or the semantics of it is the language modeling. These two models are combined and there's a decoder which will send you whatever you set as the output. There is another step which I was talking about, how to identify who is speaking what. Like Ankit, I can say hello, XYZ can say hello, how to identify that this person is saying hello or this person is saying hello. So there is something called as Melcapestrel in signal processing which you can use for high order processing to identify whether Ankit is speaking or somebody else is speaking. Again, the model is in nation stages. We are able to identify what we are speaking, but who is speaking, we can identify, but there is a very less accuracy into that. So what we can do in alternatives to this, we can provide certain unique code. Say, I give Ankit his passcode as some word, say 1051, or say I give him a passcode, say help, right? So that particular person will come and use that passcode. Again, that depends on not leaking out your passcode or whatever you have. So before moving on to how to test, are we clear with the voice recognition or any doubts on that? Cool. So most important bit about it is you train some model, but how do you know that it is right or wrong? Right? We even face this problem, and in demo I would be talking about certain challenges. So what to look out for when you're doing the custom training? If you have Amazon services or if you have GCP services, there are a lot of tests, as we talked about in the earlier session, that what kind of tests have to be done. That is the regular suite, which I have categorized as the other tests like load, security, and all those stuff. But if you're writing your own custom model, how to test that? So the most common way of testing a model, ML model, is to measure its accuracy, precision, F1 score. There are a lot of measurements, ROC curve. It depends on what kind of model you're using. So if you're using a CRN, that is a convolutional neural network, then you need to use ROC curve matrix. If you're using a normal classifier, which is a Gaussian distribution, you should be done with your confusion matrix with accuracy or precision. So it's very important to identify what metrics you have to test your model on. So I would be talking about very basic of them. First one is accuracy. So as you can see in this diagram, there are two major terms which like you should check in general for every model. One is accuracy and the other one is precision. So accuracy is how right did you have hit the bullseye? As you can see, if you are hitting your, you are very near to your expected result, that is accuracy. But precision is how much is the distance between the two hits? How close are the two hits? So you did 5 hits. All 5 hits are very close. It is more precise. But if it is not hitting the right point, it is not accurate. So as you can see in the picture, the first picture, you can see it is only one point is hitting the right space. The rest all are not hitting the right space. So it is having very low accuracy. Out of 5, only 1 is near the point which we want to hit. But also other points are very distributed. They are not close enough. So it is not precise also. So it has a low precision and a low accuracy. The next one, you have very, you're not hitting the right point, but all the points are very close. So the precision is very high, but the accuracy is low. Similarly, you have high accuracy and high precision, and you have high accuracy and low precision. So we always tend to move towards the fourth one, where we have a high accuracy and high precision. But unfortunately, that is the best optimal case which every optimizer will try to do. Normally, we would be entering into something between this, the lower to high accuracy, low precision, and high accuracy and high precision, something between this. Your optimizer will try to do that. The reason is it's mathematical dependence, as you will see into the next one. So there's something called as confusion matrix. So your model is giving, your model, think it of as a Boolean circuit. You give it some signal and it gives you an answer as 1 or 0, that is true or false. But while you're testing it, you have to create a test data set where you know that, okay, XYZ, this image is of XYZ. So your model, whether it is saying that this image is of XYZ or not, then it is a true positive. And if it is saying it is XYZ, but picture is of PQR, it is a false positive. Similarly, you can see that we get a matrix of negative is to positive, where prediction is to actual is there. Now, what is accuracy mathematically? Accuracy is how much did you predicted right. So if you see in this previous one, you have true negatives on this side and you have true positives on the left hand side. So how many true positive and how many true negatives you got out of the entire stuff is your accuracy. That is what we talked about. How many times have you hit the bullseye correctly? So, or if intended, not correctly. What is recall? Recall is out of the entire stuff that you predicted as true. Out of the entire stuff which you predicted, the model predicted true, how many of them are actually true? So this is your sensitivity. Very related stuff which we were talking of earlier is precision. Out of true positives and false positive, how many true positives are there? So these two things are very closely related. That's why it's called as sensitivity and precision. Why it is called sensitivity? Because you can see the denominator, if you increase the size of your sample data set, it will automatically reduce. Because number of true positives and number of false positives will automatically increase when the sample size increases. But that will lower the accuracy and precision. So the precision and accuracy have, the recall and precision have to go in hand so that you arrive at a right, what to say, I would not say the right, but the most optimal model that you can achieve. So how to prepare your test data set? When you are preparing your test data set, you should have right mix. I mean, if the model is trained on my image, your test data should not contain my image because it will give very high accuracy. Because it's like a child. If you say, hey, this is lollipop, and if you bring him, say, something round with a stick, he will say it is a lollipop because he is only acquainted with lollipop. So to test the model, you have to come with something which is right and mix. You can have some images of lollipop and some images of that wooden stick which we were talking about. So there has to be a right mix, then only we'll know or testing or validation is useful in any sense. There should be a non-uniform distribution. So a non-uniform distribution means that, say your image vector, say my image is there, my image should have some variations. It should not be like you started dimming the light and took my pictures in the same pose. They should be in different light conditions. They should be in different angles, tilted bit a little. So that is what I meant by a non-uniform distribution. Foreign element introduction. So intentionally, you can introduce certain images on which model is not trained on, to identify whether the model is able to actually distinguish between an XYZ person who looks like me or not. Third thing is leveraging pre-processing. This is a point which I came across myself, because in real world you will not get the data. Okay, so you will get one image, or second you crawl LinkedIn, you crawl Facebook, you get images or do something like that. But in real world, until unless you are linked with an educational institution or a very big organization such as Google, it's very hard to come across data. So how do we manage or create a test data set out of one image that we have? So we can leverage the pre-processing. There's a package called Keras for processing of images. I'll just show that how we can augment images by tilting the image, by reducing the brightness of the image, and we can create the data set for testing on it. So before I go on to demo, is there any question on to this?
So the test that you are mentioning, so is there something that you just using data by mistake? I intentionally introduced some noise in the image. So there have been cases where a chimpanzee was detected as polar bear, just because some 0.007 noise was introduced. So those kind of tests, how do you do? I mean, will content.
Okay, so there are two ways of handling with it. One is choosing the right probability distribution. So that's why I said your distribution should always be non-uniform. And third is the sampling, how you have divided your validation set versus your test data set. So, say for an example, as you said, polar bear and chimpanzee. If we train the model on, say, chimpanzee, its variant of chimpanzee, bear, and its variant of bears, it would be able to distinguish between bear and chimpanzee. So the most important bit about machine learning is there is always, you should always train it the way you intend it to be. Okay. So there's a famous problem from 1996. It's called the CIA problem. CIA was using this image recognition technology to identify tanks which are hidden across the area. It classified bush as a tank because it was trained on images of tank hiding in a bush. Right. So you have to be very careful on what you train your model on, and what do you expect out of your model. Are you training to identify chimpanzees, or are you able to identifying? So if we have trained it, if we have trained it on say human faces, and if you show it a chimpanzee face, there's a high probability that it may mark somebody as that chimpanzee, right? So you have to be very careful about the use case, train your model accordingly, and then validate or test in that context. When your use case increases, then there is something called as transfer learning. You can always, the thing which we will be doing now. So we have a pre-trained model. How to extend it to our use case is called a transfer learning. You add a convoluting layer into your neural network to handle that particular case. So this is what we would call extensibility of models. Maybe. Like we have extensible code, you have extensibility of models. I'm sorry, my Zoom has exited. I'll just reopen it to share the code. Okay. So we will quickly look into the code. Before that, I'll start in the background the overall engine so that it gets started by that time. Okay, so yeah, so the first step is while we were talking about this code is from OpenFace and customize it to our needs. Again, it's from Stanford under MIT license. So there's a library called dlib. If you remember when we were talking about facial recognition, one important bit which came out was how do we align the faces, right? So this package OpenFace will help you to identify or take out the images out of that. So if we see over here, the first thing which we do is remove the colors out of this image, the grayscale image. So you can do this using package like OpenCV or OpenCV2, which gives you ability to play and tamper around with the images. So first of all, you convert your RGB image into a grayscale image. Further on, as I told that according to the landmark algorithm, we have 64 points onto our face. So we try to identify those 64 points onto our face. And then moving on, we use the dlib library. Okay, so dlib provides you with two options. As I told you, your eyes and lips are very important because they hold the maximum gradient on your face. So dlib provide you two options, either to align it with your outer eyes or with your inner lips and eye both. So then you find a landmark, and then dlib will rotate your image accordingly. So what it does is say your image is tilted by 20 degrees and you have a right image. So it will identify those 64 points and tilt it by that much angle so that all 64 points tilt to that particular angle. Say your derivation for your 64 points is 5 degrees. It will try to bring all those 64 points to that 0 degree axis on which your model wants to be trained. So the library used over here is CV2, that is nothing but the updated version of OpenCV, and the second one is dlib. Then moving on, as I told you that once we generate embedding out of these 64 images, right, we rotated our face by those angles and made it to 0 degree. We extract embeddings, the vectors, as we told about. So these embeddings, right? These embeddings which we generated. So there are pre-trained neural networks who were designed to extract embeddings out of these aligned faces at 0 degrees. So the TensorFlow model or OpenFace or any library which you come across would be a trained neural network. And usually they are provided in the format of .lua. Lua is lightweight processing and programmatic file. It's like any executable.exe file in Windows, which you can use to. Oh shit. Okay, so the Lua file which you have, you can just provide your images as input to that. This is a pre-trained model and it will give you embeddings as we have seen into the PPT. Forwarded by that, what we will do is we will train our model onto this. So once you have embeddings, you can easily use support vector machine, or you can use even decision trees to train on these embeddings. So here I have given, like you can see, I have various options. I can choose between the options as I give. I've trained it, I have seen the results between GMM, that is the Gaussian model, the radial SVM. So SVM normally see into the dimensions which are along the straight line. Like if it is a 3D direction, it will try to draw a 3D vector space. A radial SVM is more of a spherical vector space. So it will try to get all the images into a spatial or a radial vector space. Then you have decision trees, which is nothing but if this or not, if this or not, it creates a graph out of it. And the Gaussian naive Bayes. Out of these, all the things which I tested it across, the most relevant one was the SVM. That was a linear SVM. A radial SVM did not perform well on this. There is also a variant of linear SVM which is called as grid search SVM. So what it does, it divides your image into grids first of all, and then trains a support vector machine onto it. All these packages are available through sklearn. You can just port them in, but it's very important to identify what parameters you have to train on, how many iterations do you want to train on. Otherwise, the problem which you were mentioning, right? Like if you overtrain it on man or chimpanzee, it will identify everyone as chimpanzee. It will be not able to identify another species of chimpanzee also. So it's very important to identify the number of iterations and epochs, as we say. Epochs is a set of iterations that you have to do. So these are the certain models it was trained on. Further on, so these models, as I told you, it was nothing but a layer added on the top of the pre-trained model. It was a transfer learning. So you get that model as an output as a pickle file, which has an extension as PKA. Sometimes we will have models as an embedding with an IDB extension. So the most common models which you will get as an extension is either pickle or IDB. Then that model is nothing but a black box which acts as an if and else statement. You provide an input to that model, it will say either true or false. So your pre-processing and storage you did already. Onto your production, you have to just provide that classifier.pickle file. There is no pre-processing which has to be, there's no processing for the model which has to be done into your production environment, right? So the code becomes very lightweight. It's just like a black box, a if condition. You give it as an input, it gives you a 0 or 1. Okay, so if you can see over here in the code. So yeah, here a bit of reverse engineering would have to be done. You get an image, you convert it into grayscale, find the landmarks, and then give it to the model to say yes or no. So first of all, you see over here that I'm calling OpenFace, which is the Stanford library, neural network to get the embeddings out of the image, which would be provided you as the input. After you align your face, what you do is just call your model. So I told you it would be a pickle model.pkl. You just load that model and give that input as your image. It will say either a yes or no. That is as simple as it gets in developing the model. But the most important bit is testing it. So one real-time challenge which we faced was we trained it on images which were taken on laptop. And when we tested it on images taken from your phone, because laptop will have more width by height, the width would be more. So it's easier to draw a square grid on a laptop or a width by height image rather than a height by width image. So it performed very poorly on Android taken photos because it was taken on a height by width. Whereas it was performing in an accuracy of 80% and above on the photos which were taken on laptop because the grid was easily drawn onto that. So these are the certain things which we have to take care while testing and also give as an input to the people who are developing these models. So maybe a quick demo I'll do if my sharing works. So what I've done over here is that I have made a React app, which can be used. I made a React app which can be used across any platform. It can be used on your mobiles. It can be used on your laptops. And I've connected it to the backend with my model. And as I told you, that model is now nothing but an if and else statement. So the model result is also very quick. I've given it an intentional delay of 5 seconds. The delay taken for the model to respond is in 26 milliseconds. But I have given an intentional delay of 5 seconds so that we capture the right image. And for the purpose of demo also. So it will take around 5 seconds to recognize my face, and then we can see how it works. So this is a sample example of the code which we have written. So this is a sample example of how we can use interaction, say, when persons are entering into your system or you're entering into, as I gave you example of Heathrow Airport. This can be used in the, say you're going into an exhibition where the crowd is too large. Rather than persons identifying a tag or something like that, the machine can identify and dispense a tag. Obviously, there would be a chance for error, but that is another round of testing which has to be done to identify on that particular set whether the error rate is too low or not. If the accuracy is above 85%, you are good to go. It would be hardly that you will get a false positive. Again, if somebody looking alike me comes over, it may be a problem. But yes, we have a maturity of about 80% and so. So as I showed you, I'll also show that. So I'll just stop this one maybe. So you can see over here. So you can see over here that I have a file called classifier.pickle, which was a trained file, right? And the duration it took for identifying was 26 milliseconds, while the React was the slowest bit over here. Your model is quite fast, so you can use it into the production. I'll just show that how it was used into the code. So this face recognition, I just loaded that model. And after loading that model, it just gave me the output. So it is as simple as it gets over. So that was pretty much get the demo. Now we'll move to Q&As. If any questions.
Is there any dependency on camera resolution?
So there is definitely dependencies. So your resolutions, right, does matter. Anything taken above 8 megapixel, your camera should do. Below that, so it's very poor quality images. In generally, as I say, it has to be trained in the context. Say you're developing a product, right? So the camera which you place over there, which has to recognize, should have almost same resolution on which the model was trained on. So the entire setup has to be done in context. Say you trained on images which were having very poor resolution, but you use a high definition camera or a very low resolution camera. There are chances that it may miss the hit of recognition. Normally, it is suggested to have good quality images. because you will provide do pre-processing on it, right? So if it is very distorted, the gradients will be very poor, right? So it's normally that you have quite a big resolution, not a high definition resolution, so that you can get your gradients quite good. A resolution at 16 by 16 should be very good. So when you will crop your images, because the model has to train on a lot of images, the size of the images have to be very. So this was the bit about how we did it into the production. Now I was talking about the case wherein one single image you have and you have to generate your training data set. How do we do that? And I told that we can use Keras to do that. So I'll just.
What would be the minimum number for to get it trained?
Our desirable number is 800, but anything above 20, it can give above 50% accuracy. So 20 images is the minimum we should have. It's always better to have it in hundreds, but in real world, 20 is good number to have an accuracy of 60% or above. Many models restrict you that if you provide the images, the data set less than that size, you cannot train it. So say, please provide me more data. So if you TensorFlow or OpenFace, when you provide the model, until unless you go into the code and articulate it, it says that please provide 20 images. It will not start it and have an if clause. I'll just show how can we document images. So here you see I have used Keras. Normally it is used in pre-processing, but I have reverse engineered it to create a training data set. Keras pre-processing provides you with these many options and many more, so that as you can see, rotation range, wide shift range, height shift range, scaling, brightness, right? So the brightness is on a scale of 1 to 5 or 1 to 10. And rotation is as the degrees it can get. So you can see over here, I have ran this model to generate 25 images. So it will randomly vary the rotation range in that, the shift range in that, and it will create almost 25 images out of a single image. So we will just see how images are transformed and they look like. So if you see, this is my image over here, and this is a single image which we could get. And after generating, it rotated with various angles and width and height and a lot of stuff. It literally inverted the image, a lot of stuff it has done. So this is how you can generate, you can vary the brightness. So I did it for 25 images. As I said, 20 is the minimum number just for a try. You should have at least 10 images out of which you can generate 20 images. So you will have 20 cross 10, you have 200 images for your testing. So, but while training, you have to be very cautious. You should not use this if you are using this for testing, because your model would be trained on this kind of stuff. It will identify that this much rotation means that it is this image. You have to be very careful about what you train on what you test on. So your test data set should have an enough number of variation.
What if I have some injuries or
Yeah, obviously I said exceptions to exist. Say somebody went for let us say he was Michael Jackson. He went for a surgery, and the model would not be, as I said, he's a child. So you have to extend that layer. You have to retrain the model if you want the output to be that. See, it's the developer's responsibility. If you are aware that that particular person has got injury and you want it to be tested, you have to add that layer, unfortunately. Any more questions? Yeah.
Nice. What model? So what model do you think this smartphone, right? Everybody is having this facial recognition? So what model do you think they would use?
So they use this CV, OpenCV sort of, that is the rectangular grid translation, plus a neural network as a pickled file. So, but they are, as I said, it is an ensemble model. Your iPhone can detect you in the darkness also, right? So we were talking about how to detect angles and brightness and all those stuff. It's an ensemble model trained on all this stuff. So again, it is pickled. That's why your phone unlocks very quickly. So it's not the entire model training again, but it will take some images of you, generate images out of it, add a layer to that model, and keep it as a pickled file. It may be in whatever format. This model you can easily import into your Android phones. So because it is out of TensorFlow, Pickle it supports. You can just import this pickle file which we have, just put into your Android code, and you can develop your own app.
Do you think that during the evolution of age, right, the smartphones, does the pickle file get expanded as a smartphone does it?
I'm not sure about how they do it because it is proprietary. But normally the age of your phone is maximum say 10 years. And there's a very small variation from 0 to 5, there's a variation. From 5 to 12, there is a variation. From 12 to 30, there's a variation. And 30 to 50, there's a variation. So they do not have that problem until unless somebody discovers your iPhone after 5 years or so.
Do you think that the data was out of from any smartphone? Can they use it as centralized maybe for training their models?
Yeah.
They do that.
Yeah. But they will never speak it out, otherwise they would be penalized. So recently, that's why this Mr. Pichai, Mr. Zuckerberg, everybody was called into the Congress hearing. So they will never speak it out. They will say, we take care of your security, a lot of stuff. But you never know. Your phone might be listening to you right now.
Alexa is listening.
Yeah.
So we talked about both voice and facial. Your applications only dealing with.
No, actually, I have voice also. It will identify my voice.
As a separate thing or combined?
No, it's voice. No, separate model for voice. Voice has to be a separate model. So if I say over here, Hola amigo, and to restart it, please. Hola amigo. So this sort of stuff, it is not mapped to my name, so it will say string. I was not able to find something. Okay, so it's like that.
So is it possible to combine, for example, some videos have a voice as well as the picture verification?
Yeah.
So is it possible to do both?
Yeah. So there's a filmmaker called Karen Palmer. She's based out of Boston. She is actually working on this. So it is called as immersive film experience. It recognizes your face, it recognizes your emotion, it recognizes your voice, and the film takes course accordingly. So say they will present you into a riot situation, and according to your expression, the policeman will approach you on the screen. So I first of all stop this, my film. So the policeman will approach you. If you are calm, the policeman will go away. If you are angry, and if you say something to that, system will identify and take the course accordingly. It's again an ensemble of things. They will provide score. They will have score for each and every one. So you have disparate systems available separately. You have something for face recognition, you have something for voice. You can combine then the result of the separate CNNs or whatever model you're using into a single logic or an ensemble model, which can again be trained onto a super optimizer or a boost optimizer to give the weightage, as I say. So voice is given more weightage or the face is given more weightage, it will train on that. And
training may have to do voice as well as how possible.
it's possible. So as I said, these data resides with either educational institutes or big companies. So Stanford and Carnegie Mellon, and there is TU-Delft, which has open sourced voice samples. So they're in German, like more of an English accent, and then you can train onto that. So they will be marking like, this is angry, this is sad video, this is sad voice, something like that. So it's a lot of, we have to take help of open source, and thanks to these educational institutes who do research, because their life is here. They have to mark the entire data and create that data. So the models which are generally available are optimized to a great extent. Okay. So after that, so you would have heard about losses, right? When you train the model, there would be losses. So there is a convolutional optimization. So when you try to add a layer, it will try to attain a local minima. Now there is research on global minima. So that minima would be a representation of your accuracy and precision. So when it will train, it will automatically try to reduce that loss and move towards more accuracy and precision. ResNet and PGG. So ResNet is more of an CNN, okay, convolution neural network. It was, so there was an open challenge for image recognition somewhere around in 2000s. So the participants came up with a huge data set and they trained the model upon to perform a CNN or get a CNN out of it, which is the base of TensorFlow. So you can use either ResNet or BGG architecture in your Keras or TensorFlow. So whichever you want, it should be a CNN or a CRNN. So a CRNN will perform better on video frames. So if you take burst images, right, a convolutional and recurring neural network, a CRNN combination of both, will perform better on burst images, whereas on single images, a convolutional neural network will perform better. Okay.
Due to the interest of time, we can take the questions offline. So yeah, you will be provided with a feedback form as every session. Please write your feedbacks. And there are a few folks who reached out in the break asking how to join Thoughtworks. If you're really interested in order to join Thoughtworks family, please mention in the same feedback sheet that you're interested in joining Thoughtworks, and also provide your contact number and your email address. We would reach out to you. There's a short video which you can watch on, and we can quickly gather at 2:30 for the next sessions. There are a lot of other interesting sessions.
So thanks a lot, guys, for hearing.
Audio.
ப்ளே பண்ணி மறுபடியும் வந்து ரீப்ளே பண்ணிட்டு சுத்தமா கேட்கல சரி ஓகே இல்ல அங்க இங்கதான் இருந்தது அந்த
I guess the audio is not set up. You can break for lunch. We'll catch up on this video later.
இதுலயே ஆடியோ வரலையா
இதுல ஆடியோ வரலையே ஆடியோ என்ன பண்ணிருக்கோம் முதல்ல
எங்க எனேபிள் பண்ணுவாங்க இந்த மெஷின்லயே ஆடியோ வரல
இது எங்க போகுது பாருங்க ஒயர் அங்க சர்க்யூட்
இங்க
ஆன் பண்ணிட்டாங்களா
இங்க தான் வருது
அதுதானே அது
All begins with a call from our recruiters. Our recruiters can help you work out if Thoughtworks is going to be right for you, and vice versa. We encourage you to check our website before this interview and think about the questions you want to ask us before the call.
அது பக்கத்துல சொல்லுங்க அது ஒன்னு எடுத்து
And which you coded. We are really looking for the solid fundamentals and problem solving skills. Before this interview, and think about
ஏர்ப்ளே மட்டும் ஒரு வீடியோ போட்டுருக்கேன். ஏர்ப்ளே கொஞ்சம் வந்துருங்க.
என்ன பண்ணணும்? அப்ளிகேஷன்ஸ் போய் போகணுமா?
அது ஏர்ப்ளே Kroger 06 ஓகே அதுதான்
வரல பாப்பப். எங்க போவோம்? டவுன்லோட்ஸ் தானே.
அது இவனுக்கு வேணுமா? அது தீபக் அந்த ஆடியோ போட்ட போதுமா?
இதுதானே சாஃப்ட். என்னது? அது என்ன ரிலேட்டட்?
அது சும்மா ஒரு சாஃப்ட் மியூசிக் அது.
நீங்க மார்னிங் ஒன்னு காமிச்சீங்களே.
இல்ல அது இல்ல, இது வந்து இவனுக்கு
தீபக்கு. இது வீடியோ இருக்கு. வீடியோ தேவை.
வீடியோ வேண்டாம்.
ஓகே.
சரியா?
ஓகே ஓகே. இது அப்பட்ட நான் இது நிறுத்திடுவா ஜூம். ஆமா என் மீட்டிங் கொடுத்துட்டு திருப்பி வந்து மறுபடியும் ஸ்டார்ட் பண்ண தெரியுங்களா நமக்கு?
என்ன ஆயிடும்?
சரி ஓகே அப்படியே இருக்கட்டும். ஆமா ரொம்ப நிறைய பட்டுட்டோம் இதெல்லாம் காலையில இருந்து.
We design a highly processed
யூஸ் பண்ணுங்க.
சரி ஒரு ரெண்டு பேர் வருவாங்க. யூஸ் பண்ண
தேவைப்படுமா?
Okay, now
Actually, this is how the guys were also coming and drinking. They were going to okay. So I think this is
Stretch launch. Okay.
We design a highly processable booking experience. It's meant to be a slice of life here at Thoughtworks about understanding what we do, how we value this transparency, and how we work in an organization that is involved our priority. Our interview process looks for aligned people. In that, we are selective. Our founders talk about looking for people with aptitude, attitude, and integrity. People are often surprised that experience does not feature that.
Interviews at Thoughtworks are a two-way street. There are many steps to our hiring process, and we hope it will help you see what Thoughtworks is like and help us figure out if people fit to our unique culture. It all begins with a call from our recruiters. Our recruiters can help you work out if Thoughtworks is going to be right for you, and vice versa. We encourage you to check our website before this interview and think about the questions you want to ask us for the call. Our hiring process is based on the philosophy of show us what you can do. For developers, this begins with the coding design. Regardless of language you code in, we are really looking for the solid fundamentals and problem-solving skills.
Training is at the center of our structure. We pair on everything. Even our leaders pair up. Once we have shortlisted your code submission, we want you to come over and pair with some of our strategies. While we are looking for how well you can collaborate on a particular problem, we are also keen to see how much point.
The day you come into office, you'll have a number of interviews with thought workers later. You think hard about who you're going to meet, and there is a method to our madness. We like to challenge your brain in different ways, and this is one place I dare say we like to make it. Your assessment tests are designed to do just that, giving your brain cells a good work.
Thoughtworks is a three-pillar company. We want to run a sustainable business. We have been champions of software excellence, and we are very passionate about social and economic justice. One of our rounds is the social and economic justice round. Here we want to understand how do you perceive inequality in the world. Expect this to be a discussion on various topics ranging from the caste system to sexuality to politics and affirmative action. It's our effort to understand you better and you to understand us better.
Our hiring process is always evolving. You change it over the years and you change for the future too. We not only share our feedback with you, but we're keen to know how you find it. Our process might not always be as fast or smooth as you or we might like. Things might take their time, and we really hope prospective workers appreciate the fact that we really care about each hire that we make.
அப்படியா? அது எடுத்தா வர எனக்கு பயமா இருக்கு.
Thoughtworks is a great organization building interesting software for cool clients all over the world now as well.
It's an organization which can start a lot of opportunities.
Wanted to work with companies which sort of strive for excellence at that sort of level. I wanted to have people that could teach me to learn new things and to do more exciting stuff.
Well, the first time I met them was through like a Women in Technology event, and they just seemed like they really loved their jobs and they were super passionate about what they did.
It's keeping me fresh and keeping me looking at different things all the time.
So you learn a lot, which is not even related to like writing code.
Thoughtworks to me is like daily dose of crazy.
The diversity that I see at Thoughtworks and the Thoughtworks really cares about that is really good. I was looking for a company that cares as much about the society that we live in as the technology that they deliver.
It's inspiring to be among people who really want to do a good job.
We focus on hiring good people and maintaining and looking after them.
You get to work with some of the smartest and nicest people that I've worked in any company.
We encourage people to investigate new stuff and new technologies. People are very, very smart, right? They can push you in terms of your thinking, in terms of your beliefs.
Everybody is passionate about what we're trying to deliver. Everybody's passionate about software, technology.
We're very transparent, open and honest about everything we do with clients, which I think is quite different from a lot of other consultancies and a lot of other companies.
Everyone just has to have a voice and to use that voice to positively change society. Something we don't as a
So hope you all had a great lunch. Is it? Yes? Okay. Thought you guys have more energy after lunch. Is the lunch good?
Yeah.
Yeah? Say yeah.
Yes.
Okay. So let's have a small icebreaker. So it says now let's get back to the old school, right? Right, the old school PT kind of stuff. Am I audible till the last? Am I audible now? Yeah, probably yes. So small drill kind of stuff. When it says sit or raise your answer, and when it says stand, you all raise and sit. When it says answer, please stand. Right? So we do have some sort of physical activity and some concentrations, right? So again, sit is answer, stand is sit, and answer is stand. Alright? Shall we get started? Couple of minutes. Is it possible? Possible, not possible? Then doable, not doable?
Can try.
Can try. Okay, let's all sit. Stand.
அங்க எது பேசணும் சிட் கூகுள் எல்லாம் பண்ண முடியாது.
Okay, sit, stand, stand. Okay, answer, sit, stand. Guys, okay, again. Right? Sit is answer, stand is sit, and answer is stand. Got it? Answer, stand, sit, answer, answer. Yeah. Okay, let's all answer. Dan? Answer. Is someone feeling sleeping now? No? Everyone is awake? Not awake. Okay. Yeah, let's have the same drill. You guys feel sleepy, right? Please let me know. 11. No more. Cool. Thank you.
Thanks.
Hi all, this is Sajini and this is Sukumar. So we are both developers at Thoughtworks. So today we are going to look into virtual and augmented reality.
Before diving into what virtual reality and augmented reality is, we'll go through a few slides and try to understand what it is. So can someone tell me what application this is? Sorry? The camera. Like, what else do we see? Stars. Correct. So this is Google's Sky Map. It's a handheld planetarium which helps you detect stars, nebulae, and planets. So if you see, it takes up the real world plane and it is actually trying to project something on top of it. Okay, hold on to the thought. We are moving on. Has anyone seen this game? Quite a famous game. Yes? Sorry? Sorry, it's not updating. Please give us a minute, the Wi-Fi is flaky. Sorry. So yes, has anyone seen this game? What is special about this game? Okay. What else? Sorry. Okay. What is so special? I understand it. You walk around it. What is the technology behind this? Correct. Correct. So yes. I hope everyone knows the difference between VR and AR, right? Can someone tell me?
Yes. Yes, bringing technology to our world. Yes, going into that state.
Exactly. So what AR does is, if you see in AR, the scene or the world is actually the real world, the physical plane right in front of you, and we try to put 3D objects on top of it, on the plane. So what AR is what AR does is it superimposes 3D objects on top of the stream that you get from the real world. That's all, nothing else.
So any movie buffs over here? Anybody who watches a lot of movies here? So this is a challenge for all of them. So which movie is this? Any idea? Yeah, so this is a movie called Ready Player One. So in this, it's a movie specially made for gaming. So all the players in this game are gamers, and if you see, there's a gamer there. He's sort of inside a small container, a small sort of a van, which was his home, and he has some cool gadget on top of his eye, and he's actually playing a game. And what he actually sees is not the real world around him. It's it's the image over there. So what he sees is he's actually into the game. So what do you think is the tech behind this movie? Exactly. So it's virtual reality. So virtual reality is something that is being created virtually for a player. So he doesn't even realize that he is in another real world. He is completely immersed into a virtual environment. Everything that he sees, every object, everything is virtual, and he is also able to interact with the virtual 3D object that is created. So as he was telling, in the example, in the first two examples, right, in AR, you are in something virtual is on top of your real world. So you have your phone held out, and there is some objects that is on top of your camera image. But in virtual reality, you don't even realize that. You are in an entirely new world.
Back to VR. So there are two types of methodologies which is followed in AR. One happens to be mark based, and the other is location based. So if we see in marker based, what this happens to be the simplest approach, where certain types of patterns are detected, and we actually try to place 3D objects on top of that. So if you see a barcode or a QR code, that's when the app detects it and it just places a normal 3D object on top of it, which is nothing but superimposing the stream with this 3D image. The next one, this is the location-based approach. This is how Pokemon Go works. So it uses a combination of GPS, gyro, and other location awareness devices which help it to actually place AR objects on top of it. So you can see a plethora of information here, which uses location awareness. So these are the two types of AR methodologies that we have. So apps have grown so much that they're able to tell us which store is where, even provide real-time traffic updates saying that this location take the next left or something. It's like playing GTA. So let's see a small demo. This app uses the market-based approach. What it does is it looks for certain text and it tries to place 3D objects on top of it. So the first, sorry, it's a bit jittery. The first thing that you would notice is that this is not like the normal 2D camera which we use every day. This happens to be the AR session which is more immersive, and it tries to project the plane as it is. So I'm going to try to recognize a pattern here. So I've if you see, that's a cake. So all I've tried to do is the app tried to check for the pattern cake, and it is actually overlaid a cake on top of it. So this is the location-based approach. So if you see next, I try to detect what pizza is. Sorry, we could not get a proper model for pizza. Says we'll go back to cake. There it is. So the tech behind is nothing but simple OCR. So we've tried to leverage Google's Tesseract, and all it does is simple text recognition. And when you find the proper text, all you have to do is try to put the 3D image on top of it. So this is a simple approach which can get you started in the field of AR. So the location-based approach and all of this can come in later.
Okay. So now that we got a quick understanding of how the AR apps are built, so let's jump into the world of VR. So how do we create these virtual environments? So there are certain game engines which is called as Unity game engines. For people who play games regularly, you would have seen while the launch of any game, you'd have seen something like Unity or Unreal engines, right? So these are the game engines which are used to create any game. So in the world of Unity, there's something called as a scene. So a scene is nothing but each stage that is present in a game. A game object is nothing but anything that you see in a game is a game object. So a tree can be a game object. Your samurai player can be a game object. So any, even a simple dot if you see, so that is a game object. A game object family is nothing but an aggregation of game objects together. So what is a component? So say for example, there's a bird which is a game object. You need to give some behavior to the bird, right? So a bird flies or a bird eats, right? So all these are accomplished by adding components to it. So Unity itself provides a lot of default components, which are like common. So say for example, any game object should be placed somewhere in a three-dimensional space, right? Which means that it needs to have a X, Y, and a Z coordinate. So there's a component called as transform, which is provided by Unity to place any game object fixed in a 3D space. And say for example, there's a water bottle over here. So suppose I hold the water bottle and I drop it, it's eventually going to fall because of the physics, right? Because there's a gravitational pull that is acting on it. So it means that each and every game object can either have some attribute called as gravitational pull associated to it. So this is in turn captured in yet another component, which is called as a rigid body component in Unity. So you can also custom create your own components. Say for example, you want, as soon as you like focus on a door, you want the door to open automatically. So you can create your own components inside Unity as well. So what is a prefab? So for the people who are from the Java world, they might be able to relate it better. So there's something called as a class and there's something called as an object, right? So say a door can be a prefab here and this door can be an object here. So prefab is nothing but a collection of all the components within it. So it is a collection of all the behaviors and a game object is just an instance of a prefab. So we were talking about writing about of custom components, right? So how do we go about in doing this? Unity provides itself with an editor which is called as a mono-develop to help you write scripts for all these custom components. And the language that we can choose to add these components is, it can either be in JavaScript or in C#. So JavaScript support is not extensively there. So mostly all the components and all the big games that you would have actually seen might have used this C# to build it. So to understand, to relate all these concepts better, right? Let's try to compare it with something that we might have already played. So you might be knowing what this game is, right? So it's a typical Pac-Man game. So there's a Pac-Man in the center and all he has to do is like he has to go around collecting all these Pac dots. And if possible, he can also eat the ghost. I don't remember its name, Leaky something. And the intention is not to get eaten by the ghost and it is to collect all these Pac dots, right? So in this, what do you think is the scene for this game? So a scene is nothing but each stage in the game. So this one stage here is a scene. So once you've collected, once you've completed this stage, so you might be going to the next stage wherein the maze itself will be totally different, right? So each stage is a scene over here. So in here, what do you think is a game object?
Everything red, yellow, all used.
Exactly. So here the game object is almost everything. The Pac-Man, the ghost, the Pac dot, everything that you see on the screen is a game object. What do you think is a game object family over here? Exactly. So if you see, anything that is repetitive can be collected together, which can be grouped together, forms a family. So here, all the 4 ghosts form a family, and all the Pac dots here also correspond to a family. And what do you think are the components that can be added for this game?
Apple, mango in between.
That an apple and a mango is still a game object. So component is something like a behavior. Like here in this case, a Pac-Man eats a Pac dot. So this is a behavior, right? So this is a custom component that you would have to create. And even the Pac-Man moving itself is a behavior, right? So and the ghost chasing. So every other things can be a component. Any action is a component. So here, what would be the prefab? So to relate it better, so prefab is just a collection of all these components. So for example, there'll be a prefab called as Pac-Man prefab, which would contain the 2 components like a Pac-Man eating a Pac dot, a Pac-Man moving, and the ghost would be yet another prefab which would group all its corresponding components together. Okay. So this is just a quick intro of how we would be generating this VR apps. Now let's actually experience VR. Yeah, I would actually need one volunteer to experience the VR. So the Wi-Fi is making some issues, so I'm not able to project it here, but you can actually see it on the phone. So this is a game that I have created using VR. Okay. So this is a treasure hunt game. So this is a virtual room around me. I'm not sure whether everybody is able to see it, but I can pass it on the phone. So this is a virtual environment, and I have placed something called as okay, it's over here. Sorry. Okay. Are you able to see something that is purple on the screen? This one, right? So I have placed something, a 3D object inside a virtual room. Okay. So the game that I created is pretty simple. So it's just a treasure hunt game. The idea is to find this object on inside the room. So as soon as I found the object, I'm just clicking on it, and then the object goes and hides somewhere. So I just keep clicking on it, and it's just randomly positions itself inside the room. So if somebody would like to experience it, here's a VR box. So right after the session, you can actually experience it. So it would be as though like you're standing inside a real room and you're trying to find for object there. So you just need to wear this headset on over your eyes, and it would just feel like you're not even here. You're inside the room and you're trying to search for a 3D object, right? But if you look at this, right, there is something fishy for you. So do you think anything is fishy here? Exactly. So if you see, there is something with two splits, right? So why do you think there is this two splits present inside an app? Exactly. So basically, right, like how do you perceive depth over here? So you can actually try it. Like try closing one of your eye and try to concentrate on one image, and try closing the other eye and try to concentrate on the same image. So you won't see this exact same thing when you try to close both the eyes. It is just two different images that you see. So what your brain actually does is it takes these two images, it overlays both on top of each other to create a perception of depth. And that is called as stereoscopic vision. So this is what actually happens. So this is a set of, so you might have gone for bowling, right? So this is the image that would be seen in either of your eyes, but finally it is the brain that processes both of these images so that you can perceive depth. So you'll be able to know that this is before this. So in a VR, this is very important, right? Because finally what you're rendering here is just an image, but you want a feel that you are actually inside the image. So basically, the stereoscopic vision has to be there in any VR app. So if you see here, there are like two displays. Each thing would be like slightly different from each other. And once you wear this inside the headset, it has specific lens to focus both of these images so that it can be the perception of depth would be enabled. So even if you play this game, right, like if you want to experience after the session, you might note that I might have placed the same 3D object on the same space on the screen, but actually the depth would have been different, and it is because of this factor, right? So one more thing to consider. So this is just an app, right? How does it actually know I'm turning my phone? Any idea? Exactly. So it uses both gyroscope and accelerometer to identify what is the velocity at which I'm turning and across what axis am I using to take this phone. So this headset that I have, this is just a VR box, right? So all I need to do is just to place my phone inside the VR box and slam it on top of it. And this leverages the fact that my phone already has a gyroscope on it and has an accelerometer on it. All that it has is just a lens, pair of lenses. So there are different models of headset, like there's Google Daydream. A few of you might have heard about Oculus Rift, about HTC Vive, right? So everything has its own differences. So VR need not just be created on a phone. So there are a certain high range of games in which it cannot be done on a phone. So there are certain headsets like HTC Vive and all, right? So you would have to connect the game from your personal computer via HDMI cable to the headset. It does not have any lens in it. So it actually has like 2 layers of screen to view the game in a 3D image. So there are different varieties of headset, is what I'm trying to say. Okay, enough of wearing the devil hat for so long. So we have seen what is AR, what is VR, how do we create a AR app, how do we create a VR app, right? Now, let's think from yet another perspective, right? So let's wear the QA hat now. So I'm sure all of you are experts in testing, right? So knowing with this knowledge of AR and VR, how do you think testing of traditional apps is different from AR VR, or is it really different? What do you think is the difference between, so there's a team and you have apps like this. So what do you think, can you follow the same methodologies that you followed for a traditional app to test AR VR apps as well? Or if not, what else would you think about?
Response is not deterministic. Could vary.
Exactly. Response is not deterministic. So that is a good point, because especially in AR, when there is a physical world that is involved, the data set is like totally different each and every time you open your camera.
So before we go to testing, right? So we, for example, you show a demo of overlaying a cake on top of the table. Okay. So that your app requirement is to overlay cake on top of the table. That's what your app recommended. Nothing else. That's a requirement. That's what you implemented. So it is deterministic, right?
Yes, I agree to a point. So if you see right now, the lighting condition was good. It was stable. Let's say you go to a different location or a different plane where you want to place probably a dinosaur on top of a hill. Now tell me how you will do this.
Dinosaur on top of a
hill. It can be anything, right? Anything can resemble a hill. It can be from different angles. Implementation wise, yes, I agree. You have a 3D access, you can place it anywhere you want. But when you test it, you have a mock data and you actually test it against it, right?
test it against. So when you say mock data, you mean to say
the coordinates, the object, the place. Let's say I want to place it at XYZ.
because that is what we're trying to relate, right? So when we do your development, right, you had your done development based on a set of assumptions, right? That is what you're trying to validate. These assumptions, right?
Right.
Right, from a testing perspective. So when you are doing a development for, let's just take AR alone. So when you want to overlay cake on top of table or cake overlay on top of the hand, right?
Mm-hmm.
So how do you do that? So how do you know that of the people over here is a hand? And how do you identify that?
So this would be a bad example. If you see, we've actually employed a vision framework, which happens to give you the exact 2D point where you want to place the object, nothing else. Whereas if you go to a little complex app, like for example, if you want to test a real traffic scenario, then there your input will keep on changing, right? Let's say you're traveling in a road and you want to find different places. You might be seeing this place in one angle today.
Do you want to say you want to overlay helmet on top of a rider, right?
Let's say you want to find a shop and there is a 3D image, 3D overlay on top of the shop saying that this is a saloon. Today you might be seeing a little closer. Tomorrow you might be seeing from a different angle, which says that your input is actually constantly changing.
Okay.
Right? So it is very hard to test an input that is constantly changing. Do you agree?
I agree. So what we are trying to test here is this a shop? That is what we're testing, right? Or
no, I want to say, am I actually placing the shop at the right place? Am I actually placing it at the correct angle?
what is the right and what is the right angle?
So I want to place it on top of the shop. So the angle, the difference is the angle keeps changing. If you see in a 3D image, it is fixed. Correct? And also the access that you have is like a menu or an icon or something. Whereas here it is different. You will have to calculate the distance. Let's say you want to reach the saloon. You might reach the saloon in different ways.
So I assume that we have to play. Sorry, guys. When someone wants to stop. The point here is you can't always what the requirement not I'm only using as a product, as the end user, I have to place on top of something, right? I could look at the shop nearby and far. Two use cases, right? Yeah. Even nearby or far, I should always place that hat properly on top of the particular.
Exactly. So how do you determine that it is actually on top of the building?
So is it not that? I think we should use some software
No,
to find that, right?
So yes, if you see in a game, the game engine actually tells you that this is the right spot that denotes the top of a saloon. But in real world, it is not predictable. There are so many conditions that will actually not let you know the exact coordinates. So that is the actual challenge. Do you agree?
So for example, right, the same scenario that he was talking about, in daylight, it will be totally different. Around the evening time, where the lighting is like low, in a low lighting scenario, it will be totally different, right?
So the saloon, the overlay might even not come up on top of it. It could come in the next building, probably. So when we have these challenges, even for development.
For example, right, if I'm testing a deterministic, for example, say an API, I will go for bound determination. More value, less value, null value.
Okay.
This is what I test.
Yes. So let's take this location-based approach. Whereas you're talking about the approach where I get the information, the actual GPS coordinate, the actual, let's say, gyro pointing and all. But the problem is these stuffs can be tested. But the place where you actually put the 3D object is a little tricky because every time it is going to be a little different, which happens to be the change in input. Okay, I think we'll go through a few more slides to actually explain why it is so hard. So there have been successful tests which have been performed on simple objects which are stable. But if you, let's consider a moving car. Now this moving car happens to be something that moves on the real road and you want to put an overlay on top of it. Now tell me whether this is going to be a deterministic value. No, right? So as you progress, we're not going to stop here, right? Today we might test this app and get over it. But tomorrow it is going to become more and more complicated, and that is the issue which we are trying to address.
Is it addressed? Or are you trying to use the machine learning here, or how do you?
It is not yet addressed, so that we'll actually bring it at the end. We are here to talk about the challenges that is being faced today in the world, and try to come up with what we have.
Yes. And one more example to explain you better, right? Suppose you see an example app that I can think about. Suppose there's a poster on a road, and you are actually sitting inside a bus, and you just want to see what that poster is, like maybe see the details, trailer of the movie or something like that, right? So the bus is actually moving. So you're having an app, and you just want to augment some information on top of it, on top of a poster. So in this, what is deterministic? Yeah. So that's the difference between a regular app and what you're trying to augment. Any other thoughts on what would be the difference between a traditional app testing and AR/VR testing?
Okay. So before going into the different hardwares we have, let's try to understand from a QA perspective how you will actually test the existing applications that we have. Exclude AR and VR. What would be the ideal point to write, let's say, write an UI automation test on top of it? What would be your approach?
I think we just go and look at the use case and then automate it.
Okay. So how would you actually access this UI? Through which would you access?
Browser.
Okay. Getting a little deeper at the app level, what would you use in the app to actually automate it? So the UI elements, right?
Yes.
So what are the UI elements in AR and VR? Yes, game object. Okay, to some point, yes.
Any sprite in a 3D space.
So how do you interact with them? You have a button, you can tap a button, it will probably take you to the next screen.
By querying the behavior
Of
whatever we have fed it, like the component, whatever behavior is associated with the object.
yes. So do we all agree that it is going to be a lot more complex than what we have today? Right. So this is the problem that is being currently faced. there is no standard framework yet to test AR. So the challenge is actually open. So as we move in, we'll go through a few challenges here. The first thing happens to be the different types of hardware.
Do you need to test AR? Do you want to play AR?
Play AR in the sense?
Do you want to just go and play the games, or do you want to test the games?
We are already playing. There is no such automation of the kinds for testing.
Yeah,
So
you just go and play the game, right? So you won't test the game.
we do test the game, but if you
Yeah, so playing the game is a sort of a manual testing, right? So even if you had seen the evolution of testing, initially everybody was doing manual testing, but later more and more efforts were put by the testers, and then there came an automation suite, right? So suppose say this game is like right now it's just a simple treasure hunt game. So maybe you can go and play the game. This is just a simple overlaying of a cake on top of it. This can be done manually. But imagine games wherein it's like Big Bang. You're planning to support an entire game. Suppose like if you've seen the movie, the Ready Player One movie, there was an entire game sequence. So how do you go and like manually test it? It's still a challenge, right?
agree. So if you see, it is not possible to play the game all over again every time we go for a release. So it is high time that we try to automate stuff. So the first challenge would be the different types of hardwares that we have in the VR world. There is no centralized governing body that states that these are the regulations that have to be followed by these devices. Whereas we have for a few mobile devices, but if you see, there are a plethora of devices, different types of devices. Some of them are headsets, some of them are like Oculus Rift, where you actually have a headset and whatever there is in your laptop is being mirrored. So these are all different cameras, different resolutions, different objects. So we don't have a standardized framework that is capable of automation, automatically testing all these different types of hardware. So this happens to be the first challenge in AR VR testing. So yes, that's a little about hardware. So coming to manual testing is again not easy in AR and VR. If you see, the difference between a normal application and VR application is the relative motion. So you're standard, or you're probably sitting in one space, and the objects that are moving in front of you are at a different pace. Some of us who are gamers would not feel it, but regular people would actually feel something called as motion sickness. So for those of you who do not know what motion sickness is, let's say some of us would have traveled in a car which travels at high speed, or even in a sleeper bus. There you would have felt this feeling of vomiting, your head, you feeling dizzy. So these are all symptoms of motion sickness. And yes, so yes, how do you think we can do a motion sickness testing? Who would be the right person to actually do it? Safety first. Yes.
Robot, like not a human.
Okay, how do you think the robot would get motion sickness?
I mean, it would be impervious to this.
Okay, that's a good pitch.
For the future, yeah.
Actually, what happens?
So in motion sickness, let's say you play a game like Counter-Strike. I hope most of you would have played. In Counter-Strike, if you see someone who plays for the first time, and if he's looking around, you would actually feel dizzy.
So it's a feeling like your brain thinks you're actually doing something, but your sensory organs say you're not. They are signaling to the brain that you're not. So there's a clash between the brain and your sensory organs, and it makes you feel dizzy, pale, vomiting sensation.
Okay. The thing is, it is the disconnect between your sensory organs. So your eye is seeing something, your ears it is trying to balance, and your brain is processing something chaotic. This is motion sickness. And the right person to do this motion sickness, right, like someone said, is someone who has motion sickness. So there is not yet a regulation, but there are certain companies who set quality standards. They say that these are the right set of people, and even the smallest bit of sensitivity should be removed out of these games. So yes, there is quite a bit of manual testing involved in AR and VR, and also so Let's go to the video. A small blooper. Here is an action. Guys, for the record, the last video was actually a real QA effort. So yes, first things first, you have to have a stable environment. You cannot have different types of lightings and the objects moving around. This will actually jeopardize your automation testing. And also it should be safe. We should not be punching each other. Yes, top players are actually trying to come up with standards, but we are not there yet. It is still open. It is still open to the current generation of developers to actually come with the framework which would address all of this. Okay, this is another setup where they are trying to test stable objects. So this is how a setup would look like. And there is also a quote by a Google developer who says motion testing is not that easy. It is like mixing sound in a movie. It is going to be mixing of your real world with the objects, the sound. So it is going to be a lot more complicated, and testing them is going to be even more complicated.
Okay, so let's dive a little bit deep into VR testing, right? So in VR testing, as you might have seen on the phone, it was a stereoscopic vision, right, with the two images next to each other. So the person who is actually testing would actually wear a headset and he would have found a bug. How does he actually translate this bug and tell this is a bug to the developers? So if you see over here, this is a game that the developer would have created. So this is Unity. And the developers cannot do any sort of testing in here. So if you try to play a game, the game is on, but I'm not able to move like left, right. All I'm able to do is just to click here, right? And in the phone, I see a stereoscopic image. And for the tester, they see the actual game. So how does the QA actually tell this is a bug to the developer? So to address this issue, right, like Google has created something which is called as an instant preview. So all I have to do is to install an app called an instant preview over here. And then there's an SDK which is available called as an instant preview, which you need to add it to your VR games. So once the device is like connected over Wi-Fi, so it's actually trying to find for a device in Wi-Fi. So all this does is it does a live streaming of whatever is happening on the device via Wi-Fi. So that Unity provides a small window here, wherein the developers can actually see what is being seen by the QA. So one more advantage of this, right? So the QAs need not actually wear the headset itself. All he can do is just to keep the phone over here and put an instant preview on, and then he can just tilt the phone here, but actually see what is happening on the device itself. Sorry, the Wi-Fi is like really slow, so it's still trying to like load it. I'm not able to show it. But for people who are interested after the talk, like I'm glad to give it out. And so far so good. So we have been talking about manual testing, right? So in the field of automated testing, nothing has been concretely said and in the field of AR and VR testing. So a small idea that is starting up recently is to use the automation frameworks that we use for game testing in the fields of VR. So in one such effort, out of a lot of tools that is available, AirTest seems to be a little bit in the beta stage right now. So AirTest is nothing but the concept is simple. So you try to connect it to any phone, like install the app on a phone and then connect it via ADB or something. And all it does is it does an image recognition. So I'll just show you a simple test. So for the same the VR treasure hunt game that you saw before, right? So this is how a test would look like. So I'm just capturing the treasure as an image, and this test will actually try to do an image recognition. So what it does is it tries to find this image in each and every pixel inside the game, and it not only does that, it converts it into a grayscale image and again does a matching, and then it again shrinks the image into 2x size. It expands the same image into 5x size, and it again tries to do the same matching over and over again. So this is mostly like what is it? It tries various permutations and combinations to do image matching to find whether an element is present or not. And once the element is present, here there's no concept of coordinates or something. So it's just a typical image matching, right? So for the next concept of like, if you want to touch the same object, it does the same thing over again. So it finds the object and then it does a click on top of it. So as you might be knowing, like this tests are not very stable. So since it's just image recognition, it pixelated images, it doesn't recognize, and it takes a lot of time to run these sort of images. So to address these issues, there's one more framework which is called as POCO, which has been introduced. So POCO is very similar to a Python style of writing tests. So just how do you like identifying an element? So this is not an image-based recognition. So this actually tries to identify the UI hierarchy, and it tries to find the element out of the hierarchy. So you see here, I'm trying to connect to my device. So if you see here, right, there's a POCO assistant, and once I start recording, so this is my UI hierarchy. So what I have done here is like, there's an icon called as a POCO VR. I'm not sure if you're able to see it. So there's this icon called as Vodqa VR. So this is how the syntax would be. So I'm just trying to find an element with the Vodqa VR. So it already has this hierarchy which is defined on the other corner. So this is the hierarchy of the UI view that is being rendered there. So it tries to find the icon and it does a click on it. So just like how you would write test in Selenium, so POCO is supporting this sort of a testing. But both of these are like in the infancy stage only. It doesn't have a lot of features, and but we can use these tests to leverage testing of VR apps. But for AR, it is still even more difficult because of the real world camera scene behind it. In VR, it's just a virtual world. So it might be possible using this sort of testing, but in AR, it's even more difficult.
So this is like UI path or blueprint automation.
Yes, yes. This is like an automation framework or UI testing framework. Yeah. Any other questions? Okay, thank you.
Thank you, folks. Please provide the feedbacks.
So for folks who actually want to experience VR, I'm just leaving the headset here with my phone attached. So
லூப்ல ப்ளே பண்ணுமா அவனுக்கு லூப்ல ப்ளே பண்ணுமா லூப்ல ப்ளே பண்ணிட்டு இந்த ஆப்ஷன் எடுக்கல.
ஓகே. It was one fine day. Actually, it was not a fine day. It was a troublesome day. Like I had a tussle with my tech lead. He was shouting at me that I should not have did something away, and I was arguing to him that you asked me to do this this way, like the last time I'm doing this, and you are saying you're shouting for me for doing what you had suggested me to do, and was like that's in a different context, and this is in a different context, and he plays this experience card, like you got so much years of experience, and you say like you don't understand the context, and like, I was so much pissed off, and I was walking to my home, and my kid she was running to me like Appa, and I shouted at her, like I pushed her away, and I was sitting in my sofa, pointlessly looking into my mobile phone. My wife comes to me, like I was like, just leave me alone, like I want some time. She goes in, she prepares tea for me, and she brings it to me, and I'm taking this first sip of tea. I could feel that the pinch of the ginger. It was too much, and before I could sense it is too much, the sugar she had put it into the tea, it neutralizes, it soothes that the pinch. I felt better, and then the smell of the tea itself was energizing me, and then the same moment she had put some rose petals in the tea. Like the smell of the rose petals, it actually beautified the whole smell, and I was like, my God. And all of a sudden I turned to a different person. I was a different person. Then, and after this, a single sip of tea, I turned into a different person altogether. And my daughter was like, I was calling her, Wasami, I'm calling her, and she's like, oh, Papa, you're always like this. And I call her, I hug her, I kiss her. And my wife was like, you always kiss her first, and I'm always second to you, like that. And I call my wife, and this sort of thing happens. And you guys might be wondering, like, had I came in for a storytelling competition or a talk on a VR, So the person that you got to blame is Vodqa. Like, I sit out of a client office, like I sit in SP Cinemas. So last 4 years I've been working for SP Cinemas. So I'm a thought worker, and we are a team. We are sitting in SP Cinemas, and she asked me, like, you guys are doing some work in IoT, and we'd like you to come and talk here. And actually, I'm not real expert. Deepa was doing AR, VR. Like I'm nowhere near that. They were talking about chatbots. I'm nowhere near that. Like, I'm too far away. Like, we did some implementations, but they are not, real perfect implementations, but they are sort of okay. And she said that you come, you talk about it. So if at all this talk goes really bad, like attributed to her, and if it goes real good, attributed to me, and nothing goes to her. Okay? So coming to what I got to talk here. So there are two parts. So the title that I gave was Agile QA's or Agile Testers view of Internet of Things. How do I look at it? So for me to explain it, like let me explain my evolution as a QA, and how do I see Internet of Things in my life. Okay. So I started my career at Cognizant some 13 years back. Back then, I was put into a team. So I was part of this team. We'll have a big Excel with all test cases, and I got to write automation for those test cases. And I have a set of manual testers also. Now the whole objective of us is to break the system, find defects. My success is based on how many defects do I file at the end of the day. I could even remember one day, like it was almost evening, 4 o'clock. We were not able to find any defect. My test lead, he asked me, like, let's go to top floor. Let's have tea there. Like, there was one thing, it's already a bad day, and he wants us to go somewhere else to take tea. And we go there, we take tea, we come down. He tells 3 defects to me. He asked me to, like, or something like, how come you were able to find defect? The top floor is where Dev sits, and during tea time they would discuss the issues that they have. And so that's kind of environment that I was being in. So I come down. So it's been I spent some 3 years there. So they will give me a big requirement document. We would write down test cases for that in Excel, and we would convert that into automation test suite. So I come into Thoughtworks. I work in. So I come into Thoughtworks. So I've been working in same mode.
One thing I want to correct here, right? I won't work now, and we don't do that. Yeah, but we don't do that. Yeah. Things changes.
Good, this is my story.
Things to evolve.
Yeah, sure. And so I come into Thoughtworks. I work in same mode. So we got something called the sponsor here. My team was entirely pissed off with the way that I'm working, and he takes me away to a coffee shop, and he's talking to me saying like, here the way you have to work is it's not about how many defects you found. It's not your success. It's the team success is what matters. He explains me that, and he gives me some tips like you do DevBox system. When I came out of Cognizant, I was in a mindset that my automation QA, I'm like doing manual testing is same class stuff. That's a thought that I used to carry in my mind. So here I slowly start changing. We start doing this thing called DevOps system. I don't have to wait till the defect to come to a QA environment for me to test and find it. I can very well go sit with the developer as he is completing the development. Obviously, you would not have seen a lot of things. You might not have read the requirements properly. And if I sit with him as he is completing the story, I'll be able to find a lot of defects in what he is writing. This saves a lot of lead time of the defects defects getting deployed into UAT environment, and the time I tested. By the time I tested, you would have moved to some other story. You would have missed all the context of what the story is about, and these sort of things happen. So I move from the phase of fag end of development, like where I used to do my testing and automation. I move a step in front. I'm part of working with devs itself. And then I was getting suggestions from people, like if at all a requirement is missed, you will be able to find that in the requirement document itself. So we call it as stories here. So I go work with VAs. I was able to find defects in the requirement itself. This screen should have not have been placed like this, or the validation is missing that we should have added. Those sort of steps. So I still move to another. I'll go a step before, and I'm being part of writing down the requirement itself. So as a team, I was able to succeed like that in some 2-3 projects here. And then one fine day they said like, no, the project is success. We delivered the software correctly, but actually the client failed. Like it's like, the operation success and patient death. So everything worked fine, but it still really didn't create any value for the customer. So this is the stage that I get into work in SPA Cinemas. So I work with my tech lead. He's called Bhuja, and we are asked to write a wallet for SPA Cinemas. So this is the state when Paytm it is coming up there. So by then we are writing a wallet system, and in my whole career, for the first time, I was part of a meeting in which we are talking. Okay, let's say what is the kind of wallet that you would want to use. I was part of a meeting, so it was just this. Like we didn't had BAs in that team, and by that time I was changing my role as a developer, and we were just 4 developers. And I was sitting in a part of a team, and we were talking what is the wallet that I want to use. My phase of when I get involved into a project changes. Even there I was given some requirement. Like my clients have given me some requirements to write a wallet system. They have given like what all the features it should have. Beyond that, as a team, we were sitting and discussing what is it we want as a wallet. We are users of SPA Cinemas. Like we were given that we had that edge compared to any others. Like we were customers, and we were being able to define what is a kind of system that we would want to write. So that's when we decided in our wallet we don't want any other any authentication to happen. I just want to book my ticket and do a single click, and I would want my payment to be done. I don't want to add any authentication or anything of that sort. No OTP, nothing. Initially, client really didn't accept it. What happened was, apart from all the features that we have to write, we also wrote this single click payment to happen. This we took extra hours of our own time, and we did this actually, and we demoed it to the client, and they really liked it. And for all those security loopholes, we worked around in all the backend systems. And as we launched the wallet, this became a central piece of for the success of the wallet. So what happens whenever any big movie opens, everybody would recharge their wallet and they would make their payment through wallet. So the payment doesn't go out of the system; it happens within the system, and it is just a single click for them to make the payment. And it was so seamless. The adoption was real good. Like we serve around 1 million customers now through SPA wallet. So this is a story like beyond what customer had asked for. What we thought what would make our customer successful. So this is, and from then on, the customer started believing us, and he was, we really didn't have to put our own time to write, the features that we feel that would fit in. And we were doing, he was giving us space to, play our own features that we would want to bring. And we really didn't know what is the feature that would make them successful. We are just thinking of some features and we are implementing. That's when a product manager came into our team. Like he's from Thoughtworks, he's called Ramani. And what he said was, it's not the solution itself is the problem. The problem itself is the problem, he said. Like the problem that you see is not the problem at all. So I'll give you with an analogy that you will be able to relate. So one day my daughter comes to me and she asks, we have to go to mall. I was asking her, like, if I didn't question her, like I would have took her to mall, I would have spent, some 100 rupees for the cab, and she would have asked for an ice cream, and I would have spent all those money there. But I asked her, like, why do you want to go to mall? And she tells, she wants to buy a pink color kitchen set. So for her to buy a pink color kitchen set, she wanted to go to a mall. So I asked her, like, why do you want a pink color? Why do you want to go to a mall to buy a pink color kitchen set. Like I could very well order it in Amazon. I could very well buy it in in a shop nearby. We all came with she came with an assumption that she has to go to a mall to buy a pink color kitchen set. This is the assumption that she carried. Like when I questioned her with a why of why should you go to a mall, now I have 3 more options. I could present it to her and she could pick from any of it. Like end of the day, she gets a pink color kitchen set. And I'm going another level, like hi, like I ask her, why do you want a pink color kitchen set? She says, Sanjana is having a pink color kitchen set and she is not sharing it with me. So now the problem is I don't even have to buy the pink color kitchen set at all. Like it is with Sanjana. So it's just that she is not sharing it with her. Now I could go talk to Sanjana, convince her. I could, do a gyan on, what is the value of sharing and things like that, and make her to, share the kitchen set with my daughter. And I was planning to do this, but then I asked her, like, why is she not sharing the kitchen set with you? And she told, I'm not sharing my. She has a beauty parlor set, and she's not sharing that with her. Now the problem is that she is not sharing. That's the real problem. Now, if I spend some time with her, make her understand, the value of sharing and things like that, the entire thing changes. So this whole loop of like if I just went by the face value of I have to go to mall, if I went with that, I would have solved that day's problem. Like my daughter would have been happy that I had brought her a pink color kitchen set. But this problem of she is not sharing is not solved. And this is going to happen again and again and again. Just because I asked many whys, actually the problem changed. And this is not the problem only with the kids. So it happens even with us and even with our customers. So they will have one set of problem. Then they would have made some assumptions, and when it comes to us, that's not the real problem that they would want to solve. So this is what Ramani brought into the team. Like he said, like you got to ask why, and then you understand the real reason that why he has to solve something, and then when you see from there, you've got multiple options for you to solve. So when he is in the team, like we were thrown a challenge, and he did this exact thing of why. And actually the solution, they were asking us to change something in our website. And when we did this why exercise, it turned out the problem was in the kitchen operating terminal that we had. So we had to do a fix there. So we did a fix there and the whole problem went away. And so we were in a maturity level, like where the customer now believes and gives space to me that I can ask why, and he believes that I will be able to give a better solution now. And from then on, we started the one key answer for all those whys that we had was one is to create positive experiences, to create memories. So, say for example, a memory that I had quoted to you now, my wife giving me a tea that that got registered into me as a great memory now that I get to share with you. So that sort of creating great experiences was one of their top answers for the why. And another thing was reduce negative experiences that people would have. So one such example that I would give is like when you come to a movie and if you are worried about if the toilet stinks and if you are worried about going to the toilet, you will really not be able to enjoy the movie. So this is a problem that was solved in SPS University. The second theater is the first theater to make toilets usable in Tamil Nadu. That's when all sort of theaters started following this thing, and so that's sort of removing negative experience. So we were in this plane of thinking. We got to create positive experiences. We got to remove negative experience. These sort of this is the sort of plane that we are working on. Now comes so we are thinking in these planes, and then comes the IoT. So we thought a customer walks into the theater
he looks at a mirror and it suggests him a food that he would love to eat. You know, how does it suggest? How does his face look? Does he look happy? Does he look sad? And how is the climate outside? Is it hot? Is it cold? Did he came by bike? Did he came by car? Or what had he ordered? You know, during last time in the same climate for this expression, what he had ordered last time. Like I could pull out all these data. I could do analysis of all these things, and I could suggest him a food. You know, this is the moment that I create. Like I'm really sure like the system that you're trying to write, it will not create a moment like what my wife had created for me. But if I'm able to create such moment, so that's what we tried doing it with the magic mirror that we have. I have some water. Okay. So that's something that we try to do with magic mirror. So second thing that we thought was, everybody likes popcorn in SPA cinemas and the flavors that's added there. The flavors, and there will be one friend or one person in our whole group who's really good at mixing. You know, he gets that combination of flavor right, and only if he does the mixing, it will be really good. Like, and the rest of us will have no clue of how to do this mixing, or that's all. You know, if that person is not coming in to the theater, then we are lost. So we thought we would solve this problem. We would create a mixer, like a popcorn mixer, like wherein which I can create a menu. Like let's say I'm an expert mixer, and I create a menu of this much portion of Mexico and this much portion of cheese flavors. And if I could create a a menu, and if there is a machine that could create the mixture for me, and it's not ready-made popcorn, that beats the whole whole purpose. Like if it did a flavored popcorn already, then it beats the whole purpose. And how to create that combination of flavor in front of it has to be a fresh popcorn that pops out of the machine, and I have to capture that and I have to add flavors into it. That sort of experience that we want to create there. So you might be thinking like, so if at all I'm not in this state of if I had been a tester who is worried about finding defects at the fag end, and I'm not thinking about my developer, my BA, my customer, and my end user, if I had not been thinking of any of these people, I would have never been able to come up with some wonderful IoT solutions that I would really want to implement. It would be some XYZ guy. He would have seen some technology somewhere, and he would just wanted to adopt it into a project. And it will be like, without validating all these whys, he will just assume a solution and he will be giving it to you, and it might not be an optimal solution at all. And it will be forced upon us for us to develop that solution for them. So only if you are in such a plane, we will be able to visualize such experiences. So one thing that I could think of is like when I go for a medical test, they asked me, they gave me a container and asked me to bring my tool. Like they want to do some test. Like I was really I was not comfortable at all for me to do that. And if at all, they could just very well fit in some some testing device in the toilet closet itself. So that would test it for me. Like that removes the negative experience that I would have to go through. Like these sort of like if you could operate like what defines my success. It's not finding defect or writing great automation suite, or my developer is not leaving defect, or my BA is not leaving things. Like this is if I operate in any of these ranges, I'll now be able to come up with such solutions and get that implemented. So you might be in any of these stages. And what I really wish for us to be, in that state, for us, to be able to come up with great solutions. So before I close, so there is this poet called Kaviko, Abdul Rahman, yes. This guy, he's writing a poem, and actually it's a big poem, and it ends like this. கடவுள் என் முன் தோன்றி உனக்கு என்ன வரம் வேண்டும் என்று கேட்டான். எனக்கு என்ன வேண்டும் என்று தெரியாத நீ கடவுளா போடா. Okay, so we, like if I go down to my customer and ask like, oh, what do you want? A simple analogy, like if my customer is feeling very cold sitting in my theater, there could be a pattern in which he would move in his seat. If he is feeling uncomfortable because it is too cold, I could sense that, and I could very well reduce the temperature of the whole hall. I could very well do that, So only if we operate at that level, we'll be able to, And IoT actually really opens up for us to, think, augment humans in such a manner, like for us to be able to, reach out and bring out solutions of that sort. Okay, this is all. Thank you.
We need your feedback for the session. For the next session.
Samsung foldable phone நினைக்கிறேன். ஃபுல் ஸ்க்ரீன் வச்சுக்கோங்க.
நீங்க அதுக்கப்புறம் ஷேர் பண்ணிடுங்க.
When I was just a little girl, I asked my mother, what will I be? Will I be pretty? Will I be rich? Here's what she said to me. They said, whatever will be, will be. The future's not ours to see. Hey, Sarah, Sarah. What will be, will be.
Hello, my name is Nanda. I'm a QA with Thoughtworks here. So So just so you saw an ad from Samsung, a foldable phone, which is going to be launched this month, 20th. I think it's a leaked video actually from Vietnam. So what are the different interactions that you saw in the video that you can relate to today's from the morning session? Anybody want to try? Sorry? AR, VR, one more robotics, one more. Sorry? Smart mirror. Okay. There was also voice recognition. The little girl was actually cycling and she was singing a song. That's when the monster actually came into the screen. Okay. So this is the last topic. Generally we wrap up with Deepak's session. Nobody wants to actually take a session after Deepak because it not that inspiring. Somewhat it happened to me today. Okay. So I'm not actually going to talk. So what we're going to do is we're going to do a small kind of workshop here where you will be split up into 3 teams, and probably you will actually think through what all has been covered right from this morning, and probably you try to fit in. We'll see how much you remember from all the talks that happened from today morning. So the topic was actually evolving interactions. So there was a session by Karanya about a chatbot and AI intelligent agents. There are voice-based. There are VR by Sajini and Sukumar. We never had a gesture activated though. Actually, Deepak was about to present a smart mirror one. There are a few other interactions as well, something like a beacon where you actually fix a small beacon and NFC card or something like that attached to it, so that actually we can actually basically for tracking people or tracking devices or tracking anything, you can actually use or mostly into navigation space. There is one more called multimodal and others, right? I think most of the thing has been covered from today morning. When I say multimodal, there are few apps or devices or apps which can actually not only voice, it could actually see, it could actually the other sensory things will actually be available. That's basically your multimodal interactions. Okay. So what we are going to do is actually we are going to split everybody into 3 groups, and then we are going to give each one augmented reality app, another chatbot app, and another team voice integrated app. So what we want to try is just look at the app or the video that's available, and there will be one volunteer who will be along with you, mapped to each and every team. So probably they will help you in understanding the little bit of an application. Even they don't know much about application. So together as a team, probably you need to actually see what are the different test strategies that you can actually think through right from the morning sessions you have. What are the different interactions specifically, and what are the other functional and regular test strategies that you will actually come through for all the 3 apps. Everybody fine with this? Okay. Can we split into? Okay, probably can say 1, 2, 3. Probably that's easier to split it. 1, 2, 3. 1. Okay, so all ones this side, please. Oh, sorry. Okay, all ones this side, all 2s towards my left. Maybe 3 could be a little backward.
Just a sample app. Users someone now a different idea of making this. Base where but we also have
Scanning internal objects like in airlines, because they have some that is it for checking or yes, so that is a valid test.
This basically stands for what? This is being
because we are assuming that it can be that in the earth that it can go many years.
The car is within the garage. So once the it's on the car, the smoking. It gets smoke, you get it on.
some kind of thermal sensors.
And outside the garage, actually, cameras there. It takes the car and the woman. Yes.
Yeah, first we will go to say we test the mobile app, test Alexa only, and then maybe we will test this and if the one we go, I don't know.
Do you want to measure that based on your physical what we are doing? That is usually all the time.
We'll discuss all these and then we will slowly come up with a calculation. So shall we first move on to so this is what is which others all just shall we come first to the Novena?
Rather than calling this as functional calorie calculation, calorie computation.
For example, just exactly open and he tries to close it.
Apart from this, that would be common. So we have a new question.
So whatever the status on the mobile app, the ether
Close to because there should be some so I'm
What's the data that I feed my server? And my server should give me the right calorie and all that. I think it should be considered as separate edition list. What's the but how are you going to achieve? How are you going to achieve? Whatever we have about whatever various components that they are
because this could be a security concern. Inside the garage, there is a door here. Water might not flow.
So that access is
Is there any
whatever the sound that I have, according to and my watch just shows that what's the sound. There are two parts.
like even though it is showing as you can see the setting of the
For this, it could be a REST API. It could be a simple REST API. Okay. One is what to text. Okay. Text recommendation. For example, what I also want to do and then you can use it. Because what is that particular assume I'm releasing that particular system doesn't really come in we can discuss that. So it is important, right? So we take a couple of minutes and bring this to culture. And we take a couple of minutes and discuss what make sure we get what rather than suddenly jumping into this. Wherever we are going to
does NLP cover that, or we are getting our own API for that? Are we getting more qualification? No, right? We are using Alexa and Google. So we need to do the domain how it takes. But with respect to app pointer, mobile app what app?
So stuff-wise, it doesn't matter, but organizing by time, but mobile is
we done that. We say it goes one word and no. Always the real problem. Let's assume I sold some 20,000 units and it will be an accident. It's not, it will work for you. So you mother just depends on our flow. Okay? Yeah.
What happens if there's a version upgrade? One of your Alexa or voice CD or features or whatever. Then what happens when a version? How do you do this?
The one thing that we not only for like yes, segregated these things. You said I would just that's full system. So it would be really costly for me to set up this way of thing. He was suggesting motion Somali will not be able to, like marathon. How to do it? Completely impossible. If you could break this from different pieces. So we can add stubs like we can add stubs to just have a watch and on the back end again. That is what he said. You want to give the text. Next, this text goes as And then why in turn go should something inside our history gallery. That the history gets testing of we are going to test it. I have to see the history talks in the access. Okay. Then the history, okay. Then comes something of the API now. I think push based on what I'm going to give I want to have I'm seeing those corresponding each one I can corresponding gallery. So like day by day these are all very high automation oriented. Okay, and to include all the more good sexy. We are doing a copy that is not very much office. We are doing it here. Okay, so you have all your features coming in, you have all your components. How it all is. You have any and then we
We have 10 more minutes, probably the next. You put all your not able to work.
Sorry, that happens in our life. You see that we go with and what we can say what the device is not connected. What happens? Alexa,
we can use that. Yes.
Let's get into the chatbot service. So that's a key part of it. So let's just concentrate on the chatbot service. Let's forget the mobile app. Let's forget everything. I just have just introduced the chatbot service. How to go. Let's combine it. So the NLP, everything is taken care of, and the testing is part of different features. So now so here one of the functions here is the chatbot service. So you get text inputs based on all the context, and with behavior, we have this. We talk about the strategies to want to use this. Because there is one server. Let's write down test cases for like we are from a high level strategy. Let's write down test cases that we have. So one strategy is conflict list. First point is the distance, minimum distance of the user to feet in a measurable way. We should say if the luggage is 10 meters away, they should not measure it from the 10 meters away. They should be closer enough to cover the luggage. Then only we can the application can measure how the luggage measurement. Then measurement of the object. Then lightning. If we are having a black color luggage, the lighting is already dull. We should also have a shadow, or we should measure background of the image. So based on the lighting, the application should say the lighting is dull. You should have a bright light so that the application can read it correctly.
So to ask that, right, the same that they could be there with the I'm traveling of train or
then color contrast. If the application is only handling a black color or the application is handling only yellow color, it should not be on that way, right? The application should also handle all the colors of the luggage. If the luggage is half yellow and half black, it should not only scan the black color, only itself the black color. Handle entire luggage of the entire color of the luggage. Then application should not restrict the geometric shape. If the luggage is circle shape or oval shape, it should not restrict. It should only say this is the cabin size. You can fit inside it. If it is a circle, if the circle package is fitted inside the cabin or not, it should not restrict. You are having a circle shape. You are having a rectangle shape. It is not. You should not worry about it. Whether this luggage is fitting to the cabin or not, that kind of restrictions. Then, if I'm having a two luggages, if I place one on one, if I scan it down, it should say the luggage size is overloaded. You can take over something. It should say.
Thanks, Ramesh. So, so continuing that, so the luggage our application should have all side of images, at least 3 sides minimum, to have the full picture, to measure the distance. So that's one consideration. And if at all the customer is having luggages side by side or one behind one, okay, so the app should identify that as well. So at least at a time, one luggage has to be measured, and along with the luggage, there should not be any other objects placed right now. And even in the while traveling, the user is using our applications. It will be a bit shaky, so our application should have the support to handle as well. And okay, so the luggage is identified as a correct size, then the application should prompt a proper indication to notify the user, as well as if it is identifying some error case, when the object is not the right size or you are too close to the luggage, or the lighting is bad, so it has to present prompt the proper error feedback. So the user can correct it. And our application should support as well the basic iOS and Android. And our application is going to be a single application which supports all kind of aircraft's dimensions. I mean the cabin dimensions. So while using this application, the user must select the proper the correct cabin size. Then only our application is going to be suggested. And it has to be very responsive. The result has to be within an acceptable limit. So these are the conditions. Okay? These are the manual testing scenarios we identify. And to test this, we should have the test data with us. Okay? The challenge here is that we cannot go and purchase all kind of luggages in the world. So we have to do some kind of do some kind of a hack. What we thought is like we have to build a 3D kind of image by combining the images provided by the luggage vendors. Then we have to frame our 3D images and then present it to our framework so that it can utilize that. And we have to segregate our correct luggages, I mean the positive cases as well as the negative cases, so that we can assert while running. And we should have this cabin size from all the airlines vendors. That could be the one data set. And we are going to use a simulator. There is a real challenge there because of this augmented reality, and we are not sure like how to use our simulators. So we might use some physical devices as well. And okay. So as far as automation framework, we thought of using. I mean, we were discussing like to use POCO framework or AirTest framework that we were discussing here, but the restriction is that is specific to VR, and the image identification or image recognition is only for VR as far as we know. So what thoughts we gave us, we could use some native APIs inside our own framework like Espresso or the Apple test, SU test. With the help of API, we can capture the image and we can compare it with our test positive results as well as the negative results to identify. So that is what we could come up with. So thanks a lot. Any questions? Thank you.
Thank you. We will move on to the next.
Next is the chatbot app. It is a LARC, a smart fitness and training coach app, plus a nutritionist. So what it does is basically, you will actually feed in all your activities, daily activities, what you eat, and all the activities that you actually perform. So it calculates, I think, what he needs to eat or to maintain your nutritional balance, to maintain your fitness level, and as well as it'll also have a dial-in for a doctor or dial-in for your dietitian, all those features.
I've been trying to lose weight. I used to manually track every calorie. Let me show you. So at breakfast, I had eggs, bacon, and a side of toast and coffee. Let me start by typing in eggs. And it's going to pull up some options. Oh, I guess they were scrambled eggs, but mostly egg whites. I'll just take this, 51 calories. Great. And I'll repeat this step for the bacon, toast, and coffee. It's a lot of steps, and I don't get any instant feedback. I feel like I'm trying to lose weight alone, which is challenging. However, it's really quick and simple to chat about eating healthier with Lark on the Apple Watch. Let me show you. I just tap this button, and I can speak directly to my personal coach. Eggs, bacon, and a side of toast and coffee. Lark does all the logging for me and gives me immediate feedback when I need it most. Oh, looks like I had too much bacon this week. No bacon for me the rest of the week. Super simple, and I'm on my way. And let me show you how Lark works on my iPhone. So Lark asks what I ate. Eggs, bacon, and a side of toast and coffee. And that's it. She responds instantly. Oh, and it looks like I've had bacon too many times this week. But maybe I could swap that out for something a little leaner. Great. Lark also tracks how active I've been and keeps me motivated. It's like having a buddy and a coach in my pocket. It's transformative. Download Lark for free today.
So that is a LARC. So anybody from the LARC team, go over.
Good evening. Basically, I'm a developer. I'm not a tester. Basically, I'm a developer. I'm a tester. Can you scroll a few moments of this?
Sure.
Yes, stop it. I was a discussion point of time. I have a small query like here and chilies are a bit different, right? In Allo India, we have chilies.
But by choosing or picking the chili itself or egg itself, I can able to assign that if I choose an egg or content, I assume that country egg or the broiler egg, the quantity of the protein or the value has been stored here. And second is about that the location-based ID has been fetched. So the app which can able to employ in China or in different regions, they may not have the egg, maybe a country egg. They have a different breed. So based on the locations, the user profile itself, I can able to feed the data, JSON data through fetching the data while inside the app itself. Anybody comes from testing point of view can give information.
Good evening, Tom. So as we considering the hub, we are going to testing the chatbot. Going to consider how to we are going to test in the chatbot. So we have a nice session in the morning about how to test the chatbot. So you can take input from that itself. So as it is a chatbot, so it is bus detect healthcare because it is to the users to maintain what is health condition, how he is eating, how what is the diet control is a coach. So we have to validate either the chatbot is giving correct response. So for that we have to do the different user profiles. We have created test data and we feed our questions to the chatbot, get whether the proper response we are getting. So on that domain, I guess, depending if you say I'm eating here or it could give some selecting something and doing some other stuff which you can think that this chatbot is working properly or not. And different semantics, different slangs. So if you say, I guess it should be both voice and speech. If it is a voice, you can give a different slangs and segment that is working properly. This is the different first thing. Then we think about the usability. How the app can be usable, whether you can usually is it interacting to the user, whether the user is getting proper things to access to giving the input. For example, he's going to select whether he's getting the proper response, the usability, and how the compatibility, whether its app is iOS, I guess, it's Android or iOS, whether it's on the mobile or smartwatch also we can put our chatbot, so whether it's compatible for all the devices. So that testing we'll do. Then we can do the accuracy. What is accuracy? We provide the same input by different user with boundary value, with 1 or 2 and say that whether accuracy is correct, whether it is providing for all the average. For example, I am saying I am making 2x. Someone saying 3x, so it is giving same coloring or it is giving different color. So that accuracy we have to check at the functional point of view. So that is it. And whether performance, how the performance is there. For example, if I am testing, I am accessing, if we can say we can hit with number of APIs, say this we cannot go with them, we can take an API, you can hit with number of APIs, different tools and check how the response is coming, whether the response is in SLA time or it will take more time. And migration. This is the thing because everyone we can change our app to different, because we purchase a new mobile, we can change our app. So we check that whether the app has their data. It cannot come, it can come, some others data does not come to your app by this. So the migration check should be the major thing. Another thing, data sync. When the data is syncing, for example, I think something smartwatch and it's syncing to that thing. So that we'll do. And this functional point, all the functional point. How the interaction, it's different interaction. Because we go to offline, while chatting we are going to offline, we are coming to the Wi-Fi is disconnected, whether Wi-Fi is the network, not, so how it is behaving, that's test in this point of view. So this is all the functional point. For automation point, we can say whether the chatbot server is giving proper, let's say, means like different data flows, and we can check whether getting that, whether they give the asset which the server should be expected. So these are the scenarios we'll say both some framework which will hit the component wise. We leave that unit testing has been done completely. So we can only concern the functional testing. So this is our approach for the chat. Any questions? Thank you.
One small thing I think you need to note out here is I think how the watch app behaves for the same chatbot thing and how the mobile app responsiveness or the interaction actually changes. And you can see, right?
Simple to chat about eating healthier with one.
it's asking have you eaten or not, and it's giving you eat now or ate already or something. So that's a different interaction, that right? I think you can actually type in your watch, but it actually gives you some two kind of buttons where you can actually select an option, or you can actually voice to it. Same way, the output actually that comes, right? It doesn't actually present you any charts or any more details about. Rather, it collects just the information from you. Probably it only gives you text-based output. Whereas in your mobile, actually it gives you a lot of graphs and other details. So it's a kind of a complete, what to say, the user flow itself changes. So we need to be cautious about that. We'll move on to the next one. Voice integrated app. We have a next garage app. This is basically a voice integrated, both Alexa as well as your Google Assistant will work. It will basically open the garage for you. Generally in colder countries, they have a garage opener where you could actually, generally it's a remote control kind of thing, infrared or those kind of wireless stuff. Whereas this is completely integrated with Alexa and other stuff.
It has advanced, but is it really useful or simple to use? Can it remind you if your garage door was left open? Can it tell you if your children have gotten home safely? What if you could do all of this and more with a smart garage? With Next Garage, you can take your existing garage door opener to the next level of security and convenience. It's quick and easy to install, and it's compatible with most garage door openers, even with older models. Imagine controlling your garage from anywhere in the world. Get notified who and when activated your garage, or even share control to friends and family. Beyond security and peace of mind, Next Garage lets you pick your favorite ways of activation. By tapping on your smartphone, by speaking to Amazon Alexa or Google Assistant, or by simply driving home and your garage automatically opens, welcoming you home. Don't replace your garage opener. Get Next.
Okay, so that is a prompt set. Somebody wants to present it?
Good evening, everybody. Thank you for my team to give this opportunity to present here. So Next Garage is the app which is focused on the voice integrated applications. So our developer and tester, we discussed about the architecture we are going to use. So the architect finalized is going to be not monolithic, it's a microservices. So we have decided which one gives superiority. We have 3 modules. One is for voice integrated. 2 modules. One is for Alexa. The other one is for Google Voice. The other one is for second one is for mobile. We can enable this functionality using the mobile. And third one is for which one? The physical geolocations. It's installed in the car. So 3 things we have in this module. The test strategies, how we are going to approach this module. So we have decided about the scope and the non-scope about this app. The scope of this we have discussed. We have 3 modules we have to test. And the out of scope is we are not going to test Alexa functionalities, and we are not going to test Google Voice functionalities, and we are not going to do about other non-functional things. So we are going to concentrate on functional testing, which is covered by the 3 modules. So how we are going to test? As it is the IoT device, we have to test all the functionalities separately, because each functionality gives more notification about the server. So once you install that device and you connect it to the server, the device needs to connect to the carriage and it should open and close. So this open and close, it's all the 3 modules, like a mobile device as well as physically connected that GPS device in the car, as well as the third one is for voice. It's Alexa and then Google Voice. So this is the basic functionality. And the functional test we have to first this the priority is Alexa. So we have to test giving the commands to the Alexa. The Alexa needs to close if it is open and open if it is closed. And this is the basic functionalities. We have to test the other parts using the stuff. As it is microservices, we don't care about the other models. We wanted to concentrate on the one model, particular model. First Alexa, and then we are going for the Google Voice. If it is working fine, and then we are going for the car. When the car enters that particular perimeter, the carriage should open. So we have to test this one, and then we are moving for the third one is for the mobile app. So mobile app, we can have the console part, and we can see the carriage status. If it is open, we can close, and if it is closed, we can open. And also we have a thing about a lot of the functional test is covered everything. Then we have to test the integration, the whole modules, how we can integrate all the things, whether we can get the collective notification in the central place. That thing we have, and then we can go further for after the integration. Then we can have some exploratory testing, and then we have some contractual testing. The IoT device needs to talk to each other, or it needs to communicate how the status is, whether the concurrently given the options, if it is obey or not. So this kind of contractual testing we can take it up at the last. Then we have some kind of a security testing, like how the device is positioned. So the device is positioned outside, somebody broke the device, how that will happen. It is notified to the customer, or it notified to the mobile, or it notified to the Alexa, or it notified to the Google Voice. We can think about some of the security testing like that. And suppose your card is stolen, so how it is notified to the Alexa and Google Voice or mobile app. Suppose my mobile is lost, it's possible to track that carriage. So this kind of testing is come under the security testing. And we have some other non-functional testing as well, for performance testing, load testing, and some stability testings. These testings, it's not possible to test in the field, but we have to test in the inside our lab. So we need to have some kind of API generator, and we can use for some API testing inside in the performance side. So collectively, the strategy of this particular things, first we approach how we can approach, and we have a lot of brainstorm, and we have to go via functional testing, integration testing, and then a non-functional testing and exploratory testing, and we can come up with some kind of a performance testing. Any questions? Thank you very much.
Thank you. That brings us to the end of the session. So can you all please fill up the feedback for the last session? And thanks again for this wonderful day. See you in the next podcast. Yeah. And we also have IT in the cafeteria. Please feel free to join there. And if you want to catch up with a few other networking.
Actually, I'm expecting some of the input from which one is
yeah, that is your consistent, your conclusions. Actually, I'm expecting
So it's not about saying something right or wrong, but how do you actually come to it? When given a different kind of scenario, the thinking part is not about whether the answer is exactly you don't have
Thank you. Sure. Thank you. Very nice.